Okay. Good morning. I just don't know. Let's see. We'll just see who is here today and what is the need. Okay. Whether grade 8 or 9, we are going to see who joins, and then we'll take care of that need. I actually wanted to do a little bit of area and perimeter, because some grade 8s and 9s have indicated that in their papers. For paper 2, they'll also be writing area and perimeter. Now I need to check, are there any other topics that grade 8s and 9s are actually doing for paper 2 besides area and perimeter? Like, are we also doing like volume and surface area? And is there any other topic or types of questions we need to be looking at? Because I feel like in videos that I've done, or in live lessons that I've done enough of like geometry to last you a lifetime. So I think you guys can always check out the videos on geometry and the volume and geometry. But for paper 2 topics, what hasn't been really, I think what I haven't really touched on is area and perimeter, volume and surface area. And that's like specifically talking about your grade 8s and your grade 9s. Now it's your boy Amo is saying LCM. Does that mean it's your boy Amo, you are still writing paper 1? And what grade? I need an indication in the comment section. What grade? It's your boy you because you talking about LCM, and I'm like thinking lowest common multiple. You don't know how to find the lowest common multiple. Grade 8. Yesterday. Sure. But LCM is not part of paper 2 work. It's your boy LCM is paper 1. LCM is part of paper 1. Okay. So I don't know, unless of course you guys have redefined paper 1 content. LCM is not part of paper 1. Alright, so we are going to look at, so I hope we find, I just need to get an indication. Yeah, LCM is definitely paper 1. So I just need to get an indication that doing area and perimeter and then doing volume and surface area will benefit those who are here. Alright, and maybe we'll see as well if we can't feature a little bit of Pythagoras. Okay, I just need to get an indication if there's any other topics for paper 2 that those who are here in the live feel the need that it should be covered. Like maybe specifically in your school, you were told that additionally you need to do this as well, or you need to cover this for paper 2. All right, are there any other additional topics for paper 2 that we are missing in this list? Because if they are, I need an indication so that we can see how we best cover those as well. All right, okay. So for now, since there's nothing, okay, let us start something. Yeah, I get the whole angles and shapes, guys. Angles, you mean geometry? That's what you mean, geometry. I've done enough of geometry, guys, to last us a lifetime. If you want to go and have a feast of geometry problems, I've done so many, guys. I've done so many geometry problems. I feel like geometry has been a focus. So you can always go to my YouTube channel, and you can go to any playlist for grade 8 and 9, and go and check out my playlist on grade 8 and 9 paper 2. Okay, grade 8 and 9 paper 2, because yeah, I've done so much geometry. What I know I haven't been doing is area, perimeter, volume and surface area. So I want to actually really cover that a little bit more. Pythagoras I've also been doing quite a bit in some of the papers that I've done or some of the content that I've covered. So yeah, let's make sure that we check those out as much as we possibly can. So all right, let's go into some area and perimeter. So first and foremost, guys, do we understand what area is? Okay, area is basically what we call the space covered within a 2D shape. That's what area is. I repeat, area is the space that's covered within a 2D. Now, when I say 2D, I mean a two-dimensional shape. Now, we have many two-dimensional shapes, guys. Oh, it's the space covered within a two-dimensional shape, and it's measured in square units. All right, that's what area is. Okay, so important to understand what area is. Then we need to understand as well perimeter. Now the word perimeter, the word peri, all right, is a loose term. Sorry, that's not a loose term. Peri is a prefix that means outside. Okay, outside. Okay, outside. Peri is a prefix that means outside. So this word means outside. And then meter sort of like refers to distance. Okay, so perimeter is the total distance around a 2D shape. So as a grade 8 and 9 learner, you need to know what area is. The space covered within a 2D shape. All right, it's measured in square units. All right, then perimeter is the total distance around that 2D shape. All right, the total distance around that 2D shape. It is measured in units. All right, not square units, but units. Okay, so area is the space covered within a 2D shape. It's measured in square units. So if we look, for instance, at this shape, which we refer to as a square, all right, when we're talking about area, we are talking about the space covered within this 2D shape. All right, yeah, so the minute I'm able to calculate that space covered within the 2D shape, that's when I begin to speak about what the area of that particular 2D shape. And the way it is measured in square units, guys. Very important. So area is the space covered within a 2D shape. It's measured in square units. So you can calculate the area of a square, you can calculate the area of a circle, you can calculate the area of a rectangle, you can calculate the area of a triangle, you could calculate the area of a trapezium, you could calculate the area of a parallelogram, you could calculate the area of a rhombus, you could calculate the area of a kite, right? And basically there are a variety of two-dimensional shapes whose area you can actually calculate. Now at this stage, you should know the formulas that are utilized when calculating the area of each of these shapes. So for instance, for a square, the area of a square is equal to, I want someone in the comment section to let me know, what is the area of the square? What formula do we use when calculating the area of a square? Let's see, guys, if you guys have knowledge, because honestly speaking, this is things that you should know. Let's see in the comment section, what is the formula that we use for the area of a square? the area of a square? The formula we use for area of a square? Anyone? Do I have people that are just here for the sake of being here with no knowledge? Area of a square, guys. Length times breadth. Okay, someone is saying length times breadth. Okay. Fan is also saying length times breadth. Young Flex is saying side by side. Okay, yes. We say side times side. Okay, now that is not to say that the dimensions of a rectangle. Bayanda, I don't know. Maybe I might, maybe I might not. All right. Yeah. Will you do grade 11 paper 2 revision today? Will you? I think you need to consider the wording there. Area is equal to side times side. So here we have a horizontal and a vertical dimension. Horizontal and a vertical dimension. So yes, the four sides of a square are equal. Yes, you guys are correct when you say length and breadth, because a length basically is one dimension of a rectangle, of a square, and the breadth is one dimension of a square. But because all four sides are equal, it's almost as if we say this is a side, this side, this side, and that side, and they are all equal. If you say this is a length, this is a length, this is a length, this is a length, then you're basically saying length times length. If you're saying this is a breadth, this is a breadth, this is a breadth, this is a breadth, you're basically saying breadth times breadth. In other words, we take the horizontal dimension, we multiply it by the vertical dimension. So that is the area of a square. To cover the inside of the square, we use the formula side times side to calculate the area. So that is the formula. Let's move on. What about a rectangle? What is the formula we use for the area of a rectangle? Now I'm sure you guys will be more than excited to actually tell me what is the formula for the area of a rectangle. There we go. Pretty easy. Area of a rectangle is length times breadth. And by length, we mean the long side. The long side. The long side of the rectangle. By breadth, we mean the short side. Okay? Sometimes the length, all right, and the long side, and the breadth. The breadth sometimes is referred to as the width. Okay? So width and breadth are the same thing. Okay? Width and breadth are the short side of the rectangle, whereas the length is the long side of the rectangle. So by simply saying length times breadth, that's how we are able to cover the inside of the rectangle. That's measuring it in what? In square units. Okay, so for a square, it's side times side. For a rectangle, it's length times breadth. Let's move on. What about in a circle? Or let's move on first. Let's just come here. What is the area of a triangle? Okay. So this is when I have an acute angle triangle as opposed to an obtuse angle triangle. Basically, what is the formula nonetheless of the area of a triangle? Okay, I see the Mr. Honeybee there. I just don't know what the name is. The profile picture. Profile picture. Just check out Unknown Han Buhle. Yeah, Unknown Han Buhle is saying half base times height. Pretty Imi is saying the same. So yes, you guys are correct. The area of a rectangle is half base times the perpendicular height. Very important. The perpendicular height. Okay. Height has to do with how tall something is. How what? How tall that particular thing is. Okay. And since we say it's the perpendicular height, it is the tallness of that particular two-dimensional shape from the top vertical to the base, vertical to the base. So for instance, for an acute angle triangle, the height is going to be located within the triangle. The perpendicular height is located within, because how tall this triangle is from the apex, okay, which means basically the where the two lines they meet, from what we call the vertex of this triangle to the foot of the triangle. The foot of the triangle is what we call the base. So basically we are saying the area of a triangle will be half what? So the base here is located at the foot. This is the vertex, and then the perpendicular height is basically perpendicular. The height is perpendicular to the base. So this is the base, guys. The base is the length from here to there, and then the perpendicular height, guys, is basically this height, this tallness of the triangle. So it is located within the triangle. The perpendicular height is located within the triangle for an acute angle triangle. But the minute we have an obtuse angle triangle, this is very important, an obtuse angle triangle, how tall this obtuse angle triangle is, the perpendicular height is actually situated or located, or at least we can measure how tall it is from the apex here, perpendicular to the base of the triangle. So this alone is the base from here to there. But then we have to have that construction obviously on the outside here. That basically will help us measure how tall this triangle is. So the perpendicular height, guys, is external to the what? To the triangle. So we can obviously see it's perpendicular here, and then we make this construction. But remember, the construction simply serves a purpose of helping us know what the length of the perpendicular height is. That's all it does. But whenever now we substitute into the formula half base, the base is not going to be from the perpendicular height to the end of the triangle. No. The base will be simply the base of the actual triangle. So it's half the length of the base times the height, how tall from the vertex to the base of the triangle. So that's basically how we would utilize the formula in incorporating it into the obtuse angle triangle. So that's, hopefully this is very clear. So yes, the formula is correct. Half base times height. Which base? That base. Which height? This perpendicular height for an obtuse angle triangle. But for an acute angle triangle, which base? Obviously that is the base, and the perpendicular height internal to the triangle. The construction is internal to the triangle for an acute angled triangle. So let that clarity sink in for you, so that you do not ever confuse how we are able to go about finding the area of a triangle. Okay. Then what's nice is that if it's a right angle triangle, a right angle triangle has the perpendicular height. You can see it. There it is for a right angle triangle. So it's very easy. There's the base. There is the perpendicular height for a right angled triangle. I usually call a right angle triangle, guys, a red. Okay. Still, the formula is the same. Half base times the perpendicular height. Then let's move on. What about a circle? What is the area that we use to calculate the area of the circle? Formula, guys. What's the formula for area of a circle? Let's see if my people know their stuff. The area, the formula for calculating the area of a circle. Let's go. The area of a circle. What is the formula? Let's see. Who's helping? What's the formula for the area of a circle? Okay, are we still here? Okay. Table pi r squared. Yes. Area is equal to pi r squared. Very true. Pi r squared. And the pi, right, usually there's a value that is an approximation of pi, but since we have pi, guys, in our formula, it becomes important that whenever you have to use pi, there it is. Okay, in your scientific calculator you have the symbol of pi, and that's the symbol of pi. Okay, yeah. So hopefully we can see that. Right. And then basically what pi is, it simply is it's a ratio. It's a ratio of the circle's what? The circle's circumference to its diameter. So if you have a circle, right, we say that the ratio, right, remember the word ratio, the ratio of a circle's what? Circumference. And by circumference we mean the distance around a circle. So the ratio of a circle's circumference to its diameter. Remember, the diameter is a line that comes from one end of the circle through the center to the other end of the circle. That's what we call our diameter. So pi is simply the ratio between the circle's circumference and the diameter. That's what it is. And the value of pi is 3,14159. It's this irrational number that basically, like I said, what does it stand for? Pi? Pi stands for the ratio of the circle's circumference to the diameter. Okay, that's what pi basically means, right? So we use that value, multiply it by the radius of the circle, and we square that radius. The radius, remember guys, is simply half of the diameter. From the circumference of a circle to the center, we have the radius. So that's what r is. And then the pi is simply a value, like I said, which represents the ratio of what? The circle's circumference to the what? To its diameter. All right, and basically the symbol for pi is there. Okay, yeah, okay, I hope that makes sense. Okay, remember guys that if putting it in brackets simply means multiply, because you're saying don't we put brackets. Whether you put brackets or not is of no significance, because basically what the brackets would mean, it would just mean that pi and r are multiplied. That's all that the brackets mean. Okay, and whether you put brackets or not, the fact that they are next to each other also signifies multiplication of pi and r squared. Okay. Okay, let's move on. I think we are done now. We've got the area of the square, side times side. The area of a circle, area is equal to pi r squared. The area of a rectangle, length times breadth. The area of a triangle, half base times height. Now, let's check out other areas of things that we ought to know. There's the area of a kite. Okay, and the area of a kite, guys, is simply half diagonal 1 times diagonal 2. So basically what we have here is we have two diagonals of a kite, this diagonal and that diagonal. So when we know the lengths of these two diagonals, we can simply get the product of those two diagonals and then divide them by 2, or like I said, multiply by half. That is basically the area of a kite. Okay, then let's move on. The area of a parallelogram. The area of a parallelogram, guys, is simply this, right? First and foremost, we need to establish the perpendicular height that is contained within the parallelogram from this point down to the base. Okay, we can simply say area is equal to base times the perpendicular height. Remember, the base is always the side where the foot of the perpendicular height rests. That is the base. So this would be the base of the parallelogram times the what? The perpendicular height, which is contained within the parallelogram. Okay, so its area is equal to base times the perpendicular height. Then we have what we have here, a parallelogram. Sorry, not a parallelogram, but a trapezium. The trapezium's area formula is actually area is equal to half the sum of the two sides that are parallel, and then you multiply that by the perpendicular height. So it's half the sum of the two sides that are parallel. So these are the sides. This side and this side, we say that they are parallel. So the addition, okay, the addition of these two sides are very important. Yes, I'll be sending that to you after the live neurosurgery. Okay, the addition of these two parallel sides, okay, the addition of these two, that's the sum. So you multiply the sum of the two sides, so you put those in brackets, very important, because you are talking about the summation of the two sides that are parallel. You multiply that by the what? The perpendicular height. There's a height that is perpendicular contained within the trapezium. So that is how we calculate the area of a trapezium. Okay. Yeah. Right. I hope that's very clear. I hope that is very, very clear. Okay. So this is some of the two-dimensional shapes, guys, whose formula for the area you need to know. All right, whose formula you need to definitely know. Then the last thing I want to check out here is what we call a rhombus. The area of a rhombus, guys, is simply half the what? The product as well of diagonal 1 and diagonal 2. Okay, so we need to have the diagonals in order to safely calculate the area of a rhombus. Okay, so similar to the area of a kite, okay, which is half the diagonal 1 times diagonal 2, the area of a rhombus is also calculated by half the product of the two diagonals in order to find that particular area. Okay, yeah, so these are the formulas. And once we know these formulas, it makes life very easy. This is for grade 8 and 9, guys. Those who maybe in your school you did not do area and perimeter, but I can tell you this one thing. For measurements in grade 10, you are going to have this foundation. So you may have written paper 2 already and it's done and dusted. And maybe in your school they did not do area and perimeter, and in your final paper 2 for grade 8 and 9, you did not get tested on area and perimeter. But as sure as night follows day, when you go to grade 10, area and perimeter will definitely be something that you will need to know very well as volume and surface area. Okay, so I think now we are clear about area. Area is the space covered within a two-dimensional shape measured in square units. That's what area is. Perimeter, on the other hand, right, is the total distance around a particular shape. measured in units. All right. So I think for all shapes, what's important then is for us, for calculating the perimeter of a square, you need to have all four sides so that you can be able to add the lengths of all four sides in order to calculate its perimeter. All right. Even though there's a formula, but what's important for a square, a kite, a rhombus, trapezium, parallelogram, rhombus, triangle, and all these other triangles, is simply to have all the dimensions, all your sides, because it's when you add all the sides together that you can find the perimeter of that particular shape. Whereas just one thing though is that for a circle, when we talk about perimeter, we talk about the circumference of that circle. So for a circle, it's a different story. We say the perimeter of a circle is its circumference. Okay? The total distance around that circle, we say, is the circumference. So there is a formula that we use to calculate the circumference of a circle. If the radius is available, then we say 2 pi times r. That is the formula we use to calculate the circumference of a circle, or its perimeter if you want. If the diameter is given to us, then we use pi times d to calculate the circumference or the perimeter of a circle. So this is important for the use of calculating the circumference of a circle, or in other words, its perimeter, because perimeter and circumference, when you say circumference of a circle, we simply mean the distance around a circle. And obviously perimeter is specifically saying that the total distance around any shape is what we refer to as perimeter. Okay, so specifically for a circle, the perimeter of a circle is what we refer to as the circumference. If we have the radius, we can use 2 pi times r. If we have the diameter and not the radius, we can use pi times d. And maybe you are asking, why is it that we use 2 pi times r if we have the radius, and when we have the diameter, we use pi times d? Remember, guys, that for a circle, what is the radius? Radius is simply the length from the center to the circumference. But the minute you times that by 2 from the center to the other circumference, this whole entire thing now is called a diameter. The radius is simply half of the what? Of the diameter. Okay, so diameter is the full length from the one end of the circumference through the center to the other. That's what we call a diameter. The radius is what? Is half the diameter. The diameter is 2 times the radius. Does that make sense? So the radius is half the diameter, whereas the diameter is 2 times the radius. So that is why when I have the radius, okay, this 2 and this r multiply together give me the what? The diameter. So these formulas are actually the same. They will give me the same result for the circumference, but it's just that I am aware that if I'm given the radius, I use 2 pi r. But if I'm given the diameter of the circle, instead of halving the diameter and getting the radius and substituting into this formula, I can simply use this formula, which is pi times d. Okay, is there clarity about this? Can I now move on and look at some exam type questions around area and perimeter? Can I get now that approval and allowance from you guys? Since we now know what area is and what perimeter is, can I now go and do some exam type problems? Can we look at some exam type problems together that have to do with area and perimeter? Can I do that? Right? Are we clear about the concept around area? That it is the space covered within a 2D shape measured in square units. That is area. Perimeter is the total distance around a 2D shape measured in units. Okay, and then these are the different formulas for a square: side times side. That's the area of a square. For a circle, it's pi r squared. That's the area of a circle. For a parallelogram, it's base, meaning the base, the foot of the perpendicular height. That's where the base is. It's base times the perpendicular height. For a trapezium, the area is equal to half, brackets, you add the lengths of the two sides that are parallel, then you multiply it by the perpendicular height. For a rhombus, area is equal to half the product of the two diagonals. You must have the two diagonals lengths in order to calculate the area of a rhombus, because if you don't have the diagonals, it becomes impossible to calculate the area of a rhombus. The area of a triangle, okay, if we have a triangle, we must have the perpendicular height and the base in order to calculate using the formula half base times perpendicular height. Whether it's for an acute angle triangle where the height is within the triangle, whether it's for an obtuse angle triangle where the perpendicular height is located external, constructed outside the triangle, the base, the perpendicular height is what you would include. And then for a right angle triangle, your height is obviously there within the triangle, your perpendicular height, and there is your base there, which is the values you would substitute. Then of course, for your rectangle, the area of a rectangle is length times breadth, or we could say length times the width, because we know length means the long side of the rectangle, whereas the breadth means the short side of the rectangle. Then lastly, perimeter. We just need to ensure that we have all the side lengths of the given shape in order to find the perimeter. Add all sides of the particular shape in order to get the perimeter, the total distance around that particular two-dimensional shape. Then lastly, the circumference, or the perimeter of a circle. We have a unique formula if we are given the radius of that particular circle to calculate the perimeter, or what we refer to as the circumference. If the radius is given to us, understanding that radius is simply half the diameter, we say 2 pi times r to calculate the circumference of a circle. But to calculate the circumference of the circle, if the diameter is given, we say pi times d. And that's basically the summary we need in order to do calculations. So now let's turn our attention to the first diagram that you see here. Question 1, under perimeter and area. Find the perimeter and area of each of the following figures. So let's start with perimeter. We know perimeter is the total distance around this particular shape. Okay. Firstly, we ask ourselves, what shape is 1.1? What are we looking at? What two-dimensional shape are we looking at? We need to first establish that. What shape are we looking at? We need to first establish that. Thank you. Let's say it's a square. Then 2. To calculate the perimeter, we are told that we need to have all 4 sides of the square so that we can calculate its what? Its total distance around that shape. Do we have all 4 sides of the square in this particular diagram? That's step number 2. To calculate perimeter, we need all 4 sides. Do we have all 4 sides? Yes, Mohang. We add all the 6s. In other words, the the individual sides of this particular square are 6 centimeters. And because we know that the square has the property of all 4 sides being equal, we know that all 4 sides are basically 6 centimeters. So to calculate the perimeter, what we will simply do, we can simply say perimeter is equal to. Now, because we know that all 4 sides of a square are equal, we can simply say perimeter is equal to 4 times side. 4 times side. I mean, that's just a recommendation since we know all 4 sides are equal. Or we could simply just add all 4 sides together, right? So if we say 4 times n, it means we're saying 4 times 6 centimeters, which gives us what for the perimeter? 24 centimeters. Or of course, if you are someone else, you could have said 6 centimeters plus 6 centimeters plus 6 centimeters plus 6 centimeters. It's almost as if we are running around this field. We start here, we run 6. Then we continue plus 6. We continue plus another 6. Back to where we started plus the last 6. So when we are back where we started, we're basically adding 6 plus another 6 plus another 6 plus back where we started. That is what we call the perimeter, total distance around this shape. So after adding all of this, we get what? 24 centimeters. This, guys, is the perimeter of the square. Simply put, straightforward, no stress. So we've answered the first question, the perimeter of the square. Now let's move on to the next one. What is the area of this square? So once again, what shape are we talking about? It's a square. Do we know the formula for the area of a square? Do we know the formula for the area of a square? Well, hopefully we do. We just learned the formula. So obviously we are going to go ahead and insist on writing that formula, because we know we are going to multiply the horizontal dimension by the vertical dimension in order to get the area of the square, the space covered within this 2-dimensional shape. So simply put, we are going to say area is equal to, we know the formula is side times side, so then that means 6 centimeters times another 6 centimeters. Now when we write our answer, please guys, let's not forget that this area is measured in square units. So we are not going to say 36 centimeters. No, we are going to say the answer is 36 centimeters what, guys? Because without that, the area answer is not complete. We are going to say 36 centimeters. Obviously, we are going to say 36 centimeters squared. Thank you so much, Lesego. That is how we do, so that at the end of the day, we do not miss out on the marks that we ought to attain. So please, guys, let's not forget that, as I said in my notes, area is the space covered within a 2-dimensional shape measured in, very important, square units. All right, so we need to ensure that our answer indicates that understanding. If we simply write centimeters without the square, that's where we are completely wrong. We've missed the point, because remember, it's only when we calculate the distance around that shape, perimeter, that we don't write square units, because perimeter is measured in units. All right, so whatever unit is there, okay, whatever SI unit we have there, whether it be centimeters, kilometers, millimeters, meters, we ensure that we write that. Okay, very important. All right, I think we're ready for the next question. 1.2. Look at this one. What kind of shape do we have in this diagram? What 2-dimensional shape do we see here? Because we always ask ourselves that question. What 2-dimensional shape do we have now? We have a kite. Very important. Very, very important. So to calculate, we have a kite, guys. To calculate the perimeter of a kite, we need to have the distance AB, AD, DC, and BC. We currently don't have those. So how are we going to find the lengths of AB, AD, DC, and BC? Because we want to calculate its perimeter. And as I said, what is perimeter, guys? It is the total distance around this particular shape. So I can see in the comment section, Bokang is saying we use Pythagoras. All right. Tus Wagged Out had said we see a triangle. So you guys are very much on point. So you guys can see that we have the diagonals of the kite. But we know that the property of the diagonals of a kite is that the diagonals, the long diagonal bisects the short one at 90 degrees. So we have this 90 degrees that's there. That means BD is perpendicular to AC, and therefore it means for us that these two triangles are actually congruent. Okay, and if we can calculate this length will be the same as that one, because we know for a kite the adjacent sides, the pair of adjacent sides are equal. So if we can take this one triangle and calculate AB, then we will have found what BC is equal to. If we take one of these two triangles here at the bottom, because these two triangles are also congruent, they are exactly identical. So if we can also use Pythagoras for one of these two triangles and find AD, then we can also do what, guys? We can also have found what the length of DC is. So the people who are saying triangle, specifically right-angled triangle, will help us to calculate AB. So AB here, what do we call AB? If we are looking at triangle AB, this triangle, what do we call AB? When it comes to a right angle triangle, we call AB a what? What is AB, guys? Yes, Mukang, it's a hypotenuse. How do we know that AB is a hypotenuse? What makes us know that AB is a hypotenuse? Because that's important too, that we understand how to identify the hypotenuse side when given a right angle triangle. Very good, Mukang. Mukang is saying that it's always opposite the box, which means 90 degrees. It's always opposite 90 degrees. That is the hypotenuse. The theorem of Pythagoras says that the square of this hypotenuse side, the longest side, Pythagoras says that the square of the hypotenuse side is equal to the sum of the square of these two sides, meaning this side squared plus this side squared should give us AB. So we are going to use this triangle. We've identified this triangle as the triangle we're going to use because it's congruent to that one. We only need to calculate one triangle here at the top, and then we will use this triangle as well. What is this triangle as well? Okay, grade 8th and 9th. What type of triangle is this? It is also a right angle triangle, because if that is 90, that is 90, that is 90, that is 90. So we also have a right angle triangle here. So we can use Pythagoras for this triangle too. All right. And where is the hypotenuse this time around? It is AD. So we can use Pythagoras again. The square of the longest side, the square of the hypotenuse is equal to the sum of the square of the other two sides. So let's go and actually find AB. AB squared, as we will say, as Bokang indicated in the comment section, AB squared is going to be equal to what? Okay, look at the dimensions. Okay, look at the dimensions. Okay, this is what Bokang said. AB squared is going to be equal to the square of the hypotenuse is equal to the sum, which means plus, of the square of the other two sides. So that means 4 squared plus 2 squared. Now I know it's in centimeters. I will write centimeters at the end. I just want to get the numerical value, and then centimeters will feature at the end. So that is 16 plus 4, which is 20. But remember, I have AB squared, and I want AB. So what I do is I take the square root of AB squared on both sides. Okay, quickly understanding that obviously this could either be a positive and a negative number, because when I take the square root, guys, that means there are 2 possible answers. But of course, we are going to accept and embrace the length as positive, because a length can never be negative. So our final answer is the square root of 20. Now, we can leave it as square root of 20, or we can leave it in simplified third form, which is 2 root 5. Your calculator, when you put it in, it will be 2 root 5. Or in the event that we are told specifically that you must round off your answer to 2 decimal places, then of course you would go ahead and do what? You would round off your answer to 2 decimal places and say 4,47. All right. Okay, because the 2 says what to the 7, we stay the same. Okay. Okay. Yeah. But since this is a continuing calculation, I will leave that here, right? Okay, for now. But since this is a continuing calculation, I am actually going to utilize the third form of my answer, because that is the full answer when I begin to calculate parameter. Okay, I'm going to use the third form because that is actually the complete full answer. For now, I'm going to say AB is equal to 4,47 centimeters for this calculation, since maybe it is saying in the front, round off all answer, leave them in 2 decimal places. But I know that since this is a continuing calculation, I'm going to take the third form when I begin to calculate parameter, because only my final answer will be rounded off to the decimal place that is required. But I'm just doing this just for the sake of doing it, because of the instruction at the front. Anyways, so AB is complete. So that means AB is obviously going to be equal to BC, which is also 2 root 5. Are we together? They are both 2 root 5 centimeters. And the reason why we say that is because the adjacent sides of a kite. Okay, we know the adjacent sides of a kite are equal, so AB is going to be equal to BC. So I know they are both 2 root 5. No questions asked. Now let's go on to this triangle and calculate the length of who? Of AD. Once again, our 90 degrees is there. We know that for a fact, because when there's 90 there, that means for a straight line, that's also 90, because this is perpendicular to that. Right? So we're doing the same thing, calculating the length of AD. So what are we going to say? AD squared is equal to what, guys? The sum of who? 4 squared plus what? Plus 8 squared. All right. Now there's something I forgot to do, guys, and I am actually disappointed in myself. When I utilized Pythagoras, I need not forget to write down my reason, because if I do, then my answer is incomplete. The statement is AB squared is equal to 4 squared plus 2 squared. The reason for doing that is Pythagoras. So I must never forget that, guys, because we are still in the paper 2, field, where reasons are required, especially for when we are dealing with Pythagoras, your geometry type questions. So it becomes important for me to write my reason. Same thing here. I'm going to say AD squared is equal to 4 squared plus 8 squared. This is going to be very important for me to write down my reason. Never not write down your reason. Okay. Then we do the calculation. So AD squared is equal to, what's 4 squared? It's 16. What's 8 squared? it is 64. Then we add together, we get what, guys? We get 80. All right. And then, of course, this is actually 4 root 5. Okay, when you take the square root on both sides, take the square root on both sides. Okay, my 80, which is a positive length, of course. All right, so I dismiss the negative, I embrace the positive. Okay, now some of you may be like, hey, this guy putting plus minus, what's the deal with that? Those who are doing pure maths, who are going to do pure maths next year, you're going to appreciate why we are doing this. You guys are going to do a topic in grade 10 that is referred to as trigonometry. All right, so those people who will be joining me for those classes, those early classes for grade 10 for next year, those who will actually be part of my crew of maths gamers that will be joining me during the holiday time, preparing for grade 10 before you start grade 10 at your school. You'll get exposure to those things that you are still yet to enter into in grade 10 early, before school starts. All right, so yeah, if you want to know more about the details related to those classes, which we'll be doing here online via TikTok, but in specific times, you know, those people that actually message me on the side, they are the ones that are going to get the schedule. They are the ones that are going to get the details. They are the ones that basically will get the information that relates to all of this. So please contact me on the side about it, because you need to notify your parents about it. There will be a fee attached to it. It's not going to be for free. So and like I said, fairly reasonable. Like, I feel like, you know, when they say reasonable when it comes to you know, the prices, like I said, fairly reasonable, but it will need you to speak to your parent. I don't want to be doing this just simply without your parents' knowledge. So you need to inform your parent, and there's a specific message I'd like you to then escalate to your parents so that they know about this, and an arrangement can then be made. So I hope you guys are with me there. So you are going to understand why, and I insist with my learners even at school that we put this plus minus, even though we know that we are going to take the positive answer. But we need to have an understanding that when we have square there, that is an indication of two possible answers. When we do trigonometry, which is the topic that we do in grade 10, you will understand why it is that we insist on this. All right. So anyways, AD is equal to what here, guys? It's actually equal to that 4 root 5 that I told you about. 4 root 5 centimeters, if you leave it in simplified surd form. Guys, we call this surd form. When you leave your answers with a root still present, we call this surd form. Not surd as in like a surd face, but S-U-R-D. We say this is surd form. Okay? All right. Now, AD is equal to DC, which is equal to 4 root 5. Why do we say that? The adjacent sides of a kite. That's why. Yeah. Okay. Standard. Beautiful. Okay. So now we have all 4 sides. We can now calculate the perimeter of the kite. We can now calculate the perimeter of a kite. We can do it now. It's possible. So I'm going to take all my lengths in the surd form state and add them together. Then I'm going to round off that answer to 2 decimal places, but I'm going to write down the values raw as they are. So the perimeter of a kite, all right, I would say you could either say 2 times, there's that pair of adjacent sides. So there's 2 times that pair of adjacent sides, which is that 2 root 5, plus 2 times the other pair of adjacent sides, which is 4 root 5. So this is basically the way in which you can calculate perimeter of a kite. You found the sides. You first found the first pair of adjacent sides, which were 2 root 5, both of them. And then you found the other pair of adjacent sides, which were 4 root 5. Okay? And then basically when you take this, you put this in your calculator. Guys, it's not easy to do it in your calculator. You say 2 brackets. So 2 brackets, we have the 2 root 5. We close the brackets. Oh, sorry, the bracket is outside, not inside. There we go, you see? Very important to do that. Plus 2. Then you open the brackets, you have 4 root 5. Make sure that the bracket is outside. That should be fine. And then you say equal. You get 12 root 5. But then that 12 root 5, what you want to do? If they said the answer, we must leave it in third form. Then we would write it as 12 root 5 centimeters. But you must know in the instruction usually says round off all answers to 2 decimal places. Okay, unless we are given a specific instruction, we stick to the instruction in the front cover. So our answer rounded off to 2 decimal places would be 26, what? 83 centimeters. This is the perimeter of the what? Of the kite. Okay, guys, it's no different from basically saying that the perimeter 2 root 5 plus 2 root 5 plus 2 root 5 plus 2 root 5 plus 4 root 5 plus 4 root 5. You would still get what? 12 root 5, which is 26,83 centimeters. So it's no different from that. Okay, it's no different from that. You add all 4 sides of that kite, because what is perimeter at the end of the day? It is the total distance around that particular 2-dimensional shape. All right, so that would be how we would go about it. Okay, guys, I hope this is clear. Okay, so a very important key thing here: when we have right-angled triangles within a kite and we are missing the sides of the kite, we can utilize Pythagoras. Now, if Pythagoras is not known by you and me, then it becomes problematic for us. Good. So Pythagoras is important. Knowing how to apply Pythagoras is important. Okay. Then the next question is find the area. What about the area, guys? How would we calculate the area of this kite? Right. So what's nice is that I exposed you to the formula for calculating area so that you don't have to waste our time. Okay. The question is, do we have the length of this diagonal? Do we know what the length of this diagonal is? And do we know what the length of that diagonal is? What's the length of BD? Can you see the length of BD, guys? What is the length of BD? Grade 8s and 9s. What's the length of BD? From B all the way to D. We have 8 centimeters plus 2. So BD, yes, the boy, BD is 10 centimeters. Right, so the diagonal here is 10. Then what is the length or the diagonal's length of AC? Okay, the boy, it's 8. Okay, we have 8 centimeters. Okay, we have 8 centimeters. Who's saying we can't hear you? Wow. Perhaps I don't know. Maybe you need to quiet down your background if you can't hear me. Can you speak more clearly? Are you kidding me? You are kidding me. You guys are kidding me. You really are. You're kidding me and yourselves. My goodness. Can you speak more clearly? How more clearly can I speak? These people. You see, people like you guys, you guys, I think you wake up in the morning, and when you wake up in your mornings, you think that you can come here. Yeah, guys, if you are going to do these funny things here, I'm telling you, me, I will say bye bye. I will say bye bye, goodbye. Chin. TikTok lowers the sound. Why are you guys Why are you guys the first people ever to say something like this? To say, speak louder. I've never had a comment from anyone say, speak louder in the comment section. You guys are the first people ever to say such. So yeah, I think you guys, maybe your phones, you need to maybe adjust. Your phones are probably the issue here. It's not really TikTok. I think you're just finding things to blame. Okay, but anyways, let's leave that. Yes, you can always contact me on the side for those private lessons. You can always just contact me on the side if you want private lessons. All right. Okay, so anyways, 28.3 centimeters. So we have the perimeter of the kite. Now we want the area. So you guys told me that BD is 10 centimeters, and you've told me that AC is 8. Okay, so now the area of a kite, we did establish that the area of the kite is simply what? It's half the product of diagonal 1 and diagonal 2. Half the product of diagonal 1 with diagonal 2. So you guys told me that the diagonal that we have there is BD times the diagonal of AC, and I have those lengths. All right, so that means I can then do what? I can substitute them into the formula. AC is 4 centimeters plus 4 centimeters. AC is a diagonal. BD, 8 centimeters plus 2 centimeters. That's 10 centimeters in total. So basically I have BD, which is 10 centimeters, and I have AC, which is 8 centimeters. So all I do is I simply take the formula for the area of a kite, which is half the product of the two diagonals, diagonal 1 with diagonal 2. Diagonal 1 is my length of BD. This is the diagonal. Diagonal 2 is AC. All right, so that is why you have me saying BD times AC. Half that, so that is 8. That's 10 centimeters times 8 centimeters. When you multiply those guys, 8 times 10 is 80. You divide that by 2, you times that by half, you get what? You get 40 centimeters. So that is the area of the kite, 40 centimeter squared. Done. Finished. That's the area of the kite. Good job, Mushi. Good job, Mushi. Okay. As simple as that, as straightforward as it can get. So let's not forget then this formula. Okay, those who were here at the beginning when I did the content coverage of area, when I spoke about area, the definitions of area and perimeter, and then I spoke about the formulas of the different two-dimensional shapes, we had covered that aspect, and we had mentioned that for a guide, the area of a guide is half the product of the two diagonals. So that's how we know. Okay, we had mentioned all the other areas of the other two-dimensional shapes and explained them more specifically. So yeah, let's move on. 1.3. Once again, we want to calculate first the perimeter, and then after that, the what? The area. Kebza, what is the diagonal? Kebza, what grade are you in? Validate Lava 165, please help me with to calculate mean, median, and mode. Validate Lava, just allow me to finish these quickly. All right, what grade are you in, by the way, if I may ask? Validate Lava, you can just let me know what grade you're in. Is that part and parcel of your grade 9 work, or are you in another grade? Ebza, AC is a diagonal? A diagonal is a line, okay, that comes from one end of a vertex of a particular two-dimensional shape to the other end, okay? So the A and C are opposite angles. So the line that connects opposite angles we refer to as a diagonal, okay? Angle A and angle C. Okay, Vela de Lava, I'll definitely be helping you out with that, all right? You just hang in there. I'm just currently doing area and perimeter. So I'll help you with that very quickly, okay? So angle A and angle C, these are opposite angles. Angle D and angle B are opposite angles. The line from one end of an opposite angle touching a vertex to the other end is what we call a diagonal. Yes, that is what a diagonal is. It is the line that basically joins, right, those two vertices of opposite angles, right? Like that as well. If you had a line from here to there, these are opposite angles. This is one vertex, this is another. So this is what we call if we had a line from here to there, we would call that a diagonal. Okay. Some of you need to be clear about what you are asking in the comment section. Because for instance, that Kadwa Abrara says, what is the unknown 90 degrees angle size? Really and truly, I don't have a clue what you're saying. All right. Deja Vu, thank you so much for the rose. Oh, first gift of the day. Thank you so much. Really appreciate that. Okay, 1.3. We are looking at this shape. We want to calculate its perimeter. Question is, do we have all the sides? Do we have all the sides? This is not a paper, this is a book. All right. And sorry, people, I'm sorry to some of you, right? You just need to allow me to finish, because some of you are asking questions about things that I honestly, obviously, have my own reasons for doing the things that I'm doing, and also obviously the reasons that I have for not sharing certain information, because that makes the content that I share on the platform unique. So I'll share things that I can share, but I won't share everything. So I'm sorry to this person that's asking. This is, like I said, is not a specific paper from somewhere, but it is coming from a specific book. So do we have all sides? Yes, Chris for Christ. Very true. We do have all sides, because what type of shape is this? Opposite sides are parallel. We call this a... What type of shape is this? We need to first establish that before we jump into anything. Yes, Mushi, this is a parallelogram. Thank you so much, Mushi, in the comment section, doing the most. So if it is a parallelogram, what are the properties that we know a parallelogram possesses? If this is 5 centimeters, that's obviously going to also be 5 centimeters. If that is 8, that is obviously going to be 8. So if we calculate the perimeter, do we have all sides of the shape? Remember, guys, when we calculate perimeter, we ask ourselves that question. Do we have all do we have all the sides of this particular shape in order to calculate perimeter? And for this parallelogram, yes, we do. So what we can do is we are going to say, take this 8 centimeters, run around the field, add this 5, run around the field, add that 8, run around the field, add that 5. So we're going to say 8 centimeters plus 8 centimeters plus 5 centimeters plus 5 centimeters. When we add all of those together, that is all the 4 sides of the parallelogram. That is all the 4 sides of the parallelogram. And Mushi, you are so kind enough to give us the answer there in the comment section. The answer is 26 centimeters. 26 centimeters indeed. That is our answer. All right? That is the perimeter of the parallelogram. Next question. The area of the parallelogram. Now, for area of a parallelogram, what information do we need to calculate the area of a parallelogram. Now, we recall the formula for the area of a parallelogram. The area of a parallelogram, what is the formula? Formula is equal to, the area is equal to the base times the perpendicular height. I repeat, the base times the perpendicular height. I see some of you are shocked. Hood Assassin says length times width. No, that's not the area of a parallelogram. The formula for area of a parallelogram, this is not a rectangle, guys, this is a parallelogram. So the formula for area of a parallelogram is the base times the perpendicular height. Now, some of you are probably sitting here and asking yourselves, what base? Guys, this is a perpendicular height. At the foot of this particular height, where the 90 degrees is at, we have what we call the base. So this is the base, the bottom of the foot. Where the foot of the perpendicular height rests, we have the base. So the length of the base is what? The length of the base is what? The base is 8 centimeters. Because opposite this 8 centimeters is this length, which is we call the base of this particular parallelogram. The reason why we assign it as the base is because the perpendicular height, the foot of the perpendicular height, rests here at the base. I hope we are clear. So therefore, the formula for calculating the area of a parallelogram is base times perpendicular height. So then we substitute 8 centimeters times what? The perpendicular height, which is what, guys? We have been given the perpendicular height. It's given to us. All right. There are situations when you are given a parallelogram and you are not given this perpendicular height. Maybe you get given the 5, if you know what I mean. You get given maybe here a length from here to here, and it's 3. And then you have to find the perpendicular height. And because you know the perpendicular height makes an angle of 90, it means that you are going to use what to find the height? Pythagoras. But now you are given here the perpendicular height. So it's good that you are given. But sometimes, remember, you may not be given. You may be given 5 and given maybe a length from here to there, which is 3. And then they don't have the perpendicular height. So you use, as Akamnedan is saying, you use Pythagoras. You're right? Right? So we need to always be aware of this shape that we are dealing with and what is there and what is not. So that when things are there, we use them. When they are not, we know what to use in order to get what we don't have. Clear? I hope we are clear there. So this one, we have the base. It is 8 centimeters. Where the foot of the perpendicular height rests, we have the base. Then this is the perpendicular height is 4. So the formula, base 8 centimeters times perpendicular height 4 centimeters. The area therefore is what? 8 centimeters times 4 gives us 32 centimeter squared. That is the area of the what? Of the parallelogram. Alright? So the formula, guys, please, for the area of a parallelogram, we use base times the perpendicular height. Okay. Alright. I hope we are really getting this. Move on to the next one. Next shape. What is this? And beyond what it is, what type of triangle are we trying to find the perimeter for here? What type of triangle are we trying to find the perimeter for? Remember, there are different types of triangles, but which one is this one? What type of triangle is it? Triangle ACB. Thank you, Ryan. Who's this? KG Never. KG Never, thank you. KG Never, it's an obtuse angle. triangle. Now, some of you I know are like, but say, I see a right angle triangle. Listen, people, and listen to me well. You see this dotted line? This is what we call a construction. Okay? It is not solid. It is a construction because it helps us establish that from the top of this shape to the bottom, how tall is this shape? How tall is it? So we refer to this as a construction. Okay? Yeah. Why? It helps us establish how tall this shape is from its highest point to its lowest point. Same thing here. This construction, all right, is simply helping us do what? It's helping us establish how tall. This is the triangle we are talking about, ACB. But the construction is there so that we can establish how tall the shape is. 1. So we know how tall the shape is because the perpendicular height is what? It's 4 centimeters. But more than that, we can also find what the length of the side is using the construction. Okay, as I'm sure some of you are thinking of what? Pythagoras. So if I am going to calculate perimeter, the total distance around this shape, I'm not interested in the entire shape. No, when I'm talking about the perimeter of the shape, I'm looking at from here to there, from there to here, and then from there all the way back here. Does that make sense? So the total distance around this ACB. Okay, but I am missing AC. I have CB. I have BA. So how do I find AC? Kjimpilo. That's where the 3 centimeters comes in, because my construction, more than just it telling me what the height of this obtuse angle triangle is, the 3 centimeters will help me calculate AC so that I can be able to calculate the perimeter of ACB. Let me repeat this. I am saying to you guys, the construction here helps me establish how tall my triangle ACB is, the perpendicular height, how tall it is. All right. 2, this distance from here to there, because I don't have this length, which is AC, this 3 centimeters for the right angle triangle that's here is going to help me calculate the length of AC. Using what? Using Pythagoras. So already, most of you in the comment section are telling me already what is the method, what are the steps, and how I get AC. So that by doing that, I can calculate the perimeter of what? Of triangle ACB on its own. So very good. I can see the, let's see, who is this? Mchill Guy. All right, at least that's your TikTok name. Mchill Guy has already got the length of AC. So we are going to use this triangle here. The construction, we're going to use it to calculate the length of AC. So yes, as Chill Guy has said, we are going to say AC squared, because Pythagoras says the square of the hypotenuse side is equal to what? The sum of the square of the other 2 sides. So we are going to say AC squared is equal to 4 squared plus 3 squared. Reason, Pythagoras. Don't ever forget that. Okay. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. We take the square root of AC. When we do that, I personally always encourage my learners to put plus minus, and I told you the reasons. and you will understand that much more in the future. But we know that the length is a positive answer, so we neglect the negative, we take the positive. So our answer is AC is equal to 5 centimeters. We used Pythagoras. We now have what? We now have the length of AC. Here it is, grade 8s and 9s, because this is applicable to both of you. We now have the length of who? Of AC. Here it is, 5 centimeters. What did we want to calculate? The perimeter. What is perimeter? The perimeter is the total distance of the obtuse angle triangle, the solid triangle. No constructions, guys. The solid triangle. Triangle ACB. We now have the length of AC. So the perimeter of triangle ACB is simply going to be the addition or the summation of the three sides. Simply put. So we are going to say perimeter is equal to AC plus CB plus AB. AC plus CB plus AB. AC is, we just got AC, it is 5 centimeters. Then CB is 9 centimeters. AB is 12 centimeters. We are running around this field. Okay. Well, I'm glad you are done with maths. Some people are not. Unlike you, some people are not. But congratulations for you being done. Cristiano is asking, at least Cristiano, whoever you are, why do we add? What is perimeter? Perimeter is the total distance around a two-dimensional shape. We are talking about the total distance around triangle ACB. So AC is 5. We add BC plus 9. We add BA plus 12. So the total distance around this shape is what we say is the perimeter. So that's why we add. And then we get an answer. 5 plus 9 is 14. 14 plus 12 is 26 centimeters. This here is the perimeter of triangle ACB, the obtuse angle triangle. This is both applicable to grade 8 and grade 9, guys. Okay, grade 8 and grade 9. The person who's asking me, how did I get 25 here? Go back here. We were looking at this triangle. Why? Because this triangle is a right-angled triangle. So we used Pythagoras because, yes, we only use Pythagoras when it's a right-angled triangle. AC is the hypotenuse. It's opposite the 90 degrees. So we used the square of AC and said it's equal to the sum of the square of the other two sides, which means 4 squared plus 3 squared. The 4 squared gives us 16. The 3 squared gives us 9. The addition of the 2 gives us 25. So that's AC squared is equal to 25. Okay. Then we took the square root on both sides to get rid of the square so that we can get AC. Then our final answer gives us 5 centimeters. So it is the use of the Pythagoras theorem that we applied that led us to get this 25 that we have there. So hopefully that explains to the person who was asking, where did we get the 25 from? Guys, Pythagoras, as you have said, is only used to calculate unknown sides and lengths in a ret. In other words, in a right-angled triangle. Only rets have Pythagoras used to calculate unknown sides, not any other shape. And what does Pythagoras say? Pythagoras says that the square of the hypotenuse side is equal to the sum of what? Of the square of the other two sides. That's what the theorem says. Pythagoras says the square of the hypotenuse is equal to the sum of the square of the other two sides. All right, and then I use that and calculate. Okay, so perimeter here. Now, because I found AC, I have AC, I take 5 centimeters, I add 9, I add 12 to calculate the perimeter of triangle ACB, the obtuse angle triangle. I take 5, I add 9, I add 12. Okay, then you get the final answer. Time. I'm going to pin your comment. These kids of today are lucky. Say that again. Imagine if I had so much information at my display during my matric. I feel you there, my brother. I feel you there, my brother or my sister. Okay? Yeah. And if only they knew. If only they knew. Because such occurrences were very rare. They were very rare for us. Okay? They were very rare. Okay, let's move on. Here's another shape here. Oh, sorry. We need to now calculate the area. Forgot about that. We need to calculate the area of this triangle. Okay, so we calculated the perimeter, ACB. Okay, we got the 5 here. Using Pythagoras of this triangle, we got the 5 centimeters. So we said 5 plus 9 plus 12. Okay, now we want to calculate the area of the triangle ACB. Now remember, in order to do that, we know that the formula of any triangle is half base times the perpendicular height. Right? Now just to draw this triangle on the side again, there's this construction, then it's like that, it's like that, A, C, B, like that, 4 centimeters, 3 centimeters. Remember, this is a construction, as I had said or indicated to you. We now have this 5 centimeters, we have this 12 centimeters, and then we have this 9 centimeters that's there. All right, so you see this, né? Just look at this a bit closely, right? Okay, guys, I hope we can still see clearly, né? So true. I even wish I could rewrite both maths and physics just to make my matric certificate look good. I feel you there. I feel you there. All right. Chill vibes. You are asking a question that has been answered. All right, and I'm guessing you joined just now. The 3 centimeters, as we had indicated, guys, that this is a construction. This construction serves the purpose of assisting you and me. All right, remember we initially did not have the 5, so the construction was already in the diagram because this is an obtuse angled triangle. All right, so this here is a perpendicular height. This here is an extension of this triangle. What this assists us with, this perpendicular height and this 3 centimeters there, it helps us to use Pythagoras so that we can calculate AC. All right, it's an added construction that assists you and me to calculate an unknown side if the unknown side is not there for the triangle ACB. That's 1. 2, it will also help us with the calculation of the area of the triangle, because in order to calculate the area of the triangle, there are 2 things that we need. We need the perpendicular height. In other words, we need to know how tall this shape ACB is. Now guys, how tall it is measured from this horizontal position, which is how high this particular 2-dimensional shape is, the triangle, to the base, the bottom of the triangle, meaning at this position. So how tall it is, the perpendicular height reveals that. So it is 4 centimeters tall. So that's why in the place of the height, the perpendicular height, we are going to write this 4 centimeters. That's how tall this ACB truly is. It is 4 centimeters tall. That's the perpendicular height. Then we have the base. Which base? Guys, we are looking specifically at the base of that triangle. We're not going to look at the base from here all the way to there. No, we are looking at the base of the triangle. The construction simply helped me know how tall it is, the perpendicular height. So it is 4 centimeters. It is not 5 centimeters. It is 4 centimeters, the perpendicular height. The base, on the other hand, is the base of the actual obtuse angle triangle. So from here to there, how long is that? What is the length of the base from here to there? Right? That is, we times that by 9 centimeters. That is the base, right? So that you put that into the calculator. Half base, which base? 9 centimeters, times the perpendicular height. What perpendicular height? The constructed perpendicular height, because that is the situation when it comes to an obtuse angle triangle. Please, guys, let us not understand this, because it's important. All right, for an obtuse angle triangle, our perpendicular height is external to the actual triangle. Right, the construction, how tall our diagram is. The base, on the other hand, is specifically 9 centimeters. It is not from here to there. No, that's absolutely wrong. It's from here to there. The base of the actual obtuse angle triangle is 9 centimeters. So then we go ahead, we say 9 times 4, which is 36, and 36 divided by 2, guys. Really and truly, really and truly, that answer should be quite straightforward. Mushi, thank you so much. I think you are the one that helps us out a lot there. It's 18 centimeters squared, not the other answers that I was seeing in the comment section. Area is equal to 18 centimeters squared for that triangle. Okay, hope we're good. Hope we're really good. That was for our obtuse angle triangle. Okay. Alright. Okay. Now I want to turn over our attention to something. Yola, I don't know what more. I've been explaining that thing about the 4 and the perpendicular height. All right, did you just join or what? Right, Yola. I explained in the beginning when I started the area and the perimeter, and I said the triangle, if it is an acute angle triangle, there is a perpendicular height that is internal to the triangle. From the vertex to the base, the perpendicular height for an acute angle triangle is inside the triangle. The construction can be drawn inside, because to measure how tall this triangle is, the perpendicular height would obviously be internal to measure how tall. The maximum perpendicular height from the horizontal to this horizontal, from the top to the bottom, would be internal. To measure how tall this obtuse angle triangle is, the perpendicular height is not internal to the triangle, it is external to the triangle. Because from here we can measure from the top to the base. So from this horizontal to this horizontal, this is the perpendicular height that measures how tall this particular obtuse angle triangle is. Okay, So that's why we talk about the perpendicular height being 4 centimeters for the diagram that I just looked at. So the perpendicular height, because the formula for area for a triangle is half the base. Which base? The base of the actual triangle times the perpendicular height. Unfortunately, the perpendicular height is not internal for an obtuse angle triangle. It's external. The construction to indicate how tall this is external to the triangle. So that is why we have that as the perpendicular height. Okay. Okay, of a circle. Okay, just quickly. So let's say they were asking us to calculate the area and perimeter of this circle. All right. So hopefully you can see what you do see here. The circle has a, what do we call this? What do we call this? Okay, let's just say it's 14 meters. What do we call this, guys? This line. This is obviously the circumference, but this line is called the diameter, right? And what is half of this thing? What do we call half of this? This from the circumference to the center. What do we call that? We call that the what? Yeah, that's the radius. Okay, you guys get the point. So now if I was asked to calculate the perimeter, okay, of the circle, remember guys, as I said when I was explaining the notes, perimeter means what? For a circle, it refers to the circumference of the circle. In other words, the distance around the circle. Okay, so unlike your squares, your rectangles, your triangles, here we cannot say we are adding from here to there, from here to there, from here to there. We have a circle, guys. So we refer to that circle, the distance around the circle, as the circumference. So here for this one, what's beautiful is that we've got a formula. Okay, 2 pi r. That is the formula for circumference if we are given the radius. But if we are given the diameter, we can simply do pi times d. That is how we calculate the perimeter, or what we refer to it as the circumference of the circle. Given the diameter, it's pi times d. Given the radius, it's 2 pi r. Does that make sense? Right? So if I'm going to now calculate the circumference, or the perimeter if you want, of the circle, the distance around, I'm simply going to look at the given values that I have. Since I have diameter here, which is 40, I can simply come here and use this formula, pi times d. And pi, guys, I did explain pi, that the word itself, or the term, or the concept of pi, has to do with the ratio that is referred to as the ratio of the circle with the diameter. So the value of pi is exactly that. It is the ratio between the circumference of the circle with its diameter. So it's given by that value 3,14 what. Remember that 3,14, the specific value 3,14 is an estimate. Okay, it's 3,14. That's a rational number estimate. If you want to be accurate, your scientific calculator is your friend. There is the value of pi. If you go there and you want to select that value of pi, it's very simple. You go and press shift, and then you come here to this button, you press pi. There you will see the symbol of pi come about, and then you press equal. You'll see pi there, then you go press SD in your calculator. And there it is. It's an irrational number, guys. Pi is an irrational number, right? The 3,14 and the 22/7 are simply approximations. They are estimates of pi. They are not the actual value of pi. So sometimes, if in an exam they actually tell you to use the approximation as your substitution of pi, then you go ahead and you use that estimation and approximation as the value that you substitute. But if they have not specified for you to use an approximation of pi, which is either 22/7 or 3,14, please guys, let us stick to the calculator. Come, press here shift, go press fact, and then select the actual value of pi, which is actually there. All right, yeah. So I hope you understand that. Okay, so please do that. I think the reason why you are watching this, even though you are done with maths, it's simply because you probably love maths. And secondly, I don't know what grade you are in. I don't know what grade you are in, but if you are in grade 9, then this is still good for you. So yes, 3,14159265 it continues on. There are other numbers. Of course, your calculator is limited. You can't really write all the other values, but this is an irrational. Oh, you're in matric. That's funny. So you're done with maths. You're going to varsity. So please, guys, make sure that you write the right things. Okay. So 2 pi r or pi times d. So very simple. You have 14 meters, right? If you want to use this, then go ahead. Pi times d. You just simply say pi times 14 meters. Then you grab your calculator. All right. So you already press shift, and then you go press what? This button here. That will basically, when you press shift, you allow yourself to select all the yellow things that are in your calculator. So the yellow part, you press that. What do you see? There's pi. Then you want to multiply that. Multiply it with what? With 14, right? Does that make sense? And then you say equal. You get 14 pi, right? But now if you want to get the actual value, you press ST. There it is. It's 43. If you want to round off to 2 decimal places, you'll be able to do so. 43,98 what? Meters. Meters what? No, we don't write squared. This is not area. This is circumference. Okay, nearly made a big booby there of wanting to press right squared. We don't do that. This is not area. This is actually still what? The distance around. So it's 43,98 meters. All right, makes sense? I hope it's clear for you guys. I hope you understand that. So that's how we calculate. Okay, someone else would probably know that, okay, if they know this formula, then if you are given diameter, you simply half the diameter. Okay, if you half the diameter, you get the radius. If you multiply the radius by 2, you get the diameter. If you half the diameter, you get the radius. If you multiply the radius by 2, you get the diameter back. So please guys, you can obviously work between whatever formula you want, just as long as you make sure that you are substituting the right thing where you ought to. All right. I don't do grade 7 and 6. So those people that are here and asking me to do grade 7 and 6, I don't do it. Okay, I don't do that. And those people that are here, do 2 parts of a circle, do 2 parts of a circle that are shaded. Hang on there, buddy, hang on. All right. Now let's look at question 2. Oh, sorry. So that was circumference. If you want to calculate the area of the circle, right? Now the area is obviously pi r squared. That is the formula that we use. It's pi r squared. R, please guys, the r value. Remember, we have the diameter. It's 14 meters. To get r, what do? We take the 14, we divide by 2, we get 7 what? Meters. So Tando, you better go and study for that NS, because yeah, that NS will need you. Oh, and then GEC people are writing NS tomorrow. You better go and study that NS, my friend. Please go and study. Good to see you, by the way, Swagtan. I know you're one of the faithfuls. You comment a lot, but please go and study that. Please go and study that NS. And make sure that you do well in it. So 49 pi. You can go to our calculator, of course. Go punch that in. It's like we say you see, I would have said pi, then obviously your 7 squared, and we close that bracket, we put that in, we get 49 pi plus SD. There it is, 153,94. If we round it to 2 decimal places, 153,94, right? 153,94 centimeter squared, not centimeter squared. The unit there that is used is meters. So we say meter squared. Don't be obsessed with the unit that you use it even when you're not supposed to, please. 153,94 meters squared. That is the area of this particular circle. Okay, I think it's a nice enough calculation there. Yeah, okay, right. So that covers that. The person who wanted to. I wanted just to look at something here, because there's these questions that talk about calculate the area of the shaded part. All right. So that it doesn't matter whether you did this or did that. Same thing, same squeeze. You could say pi 7 squared. Remember, this is multiplication. You could put the square inside. Remember, the square applies to the 7. If it's put outside, it applies to the 7. If you put the square inside, I mean, it's no different. It's one and the same thing. Okay? It's one and the same thing. Doesn't make no difference for this particular formula. Right? So I hope that puts your mind and your heart at ease, because I can see. All right? Leshishi, I'll be doing that surface area of a triangular prism and all of these other things. That's coming up. I need to first just do area and perimeter and cover that, right? So basics first, guys, because when we go to surface area and volume, remember that surface area borrows its power and strength from our understanding of area. The basic two-dimensional shapes of area then build up to what? To our calculations that have to do with what? With surface area of solids, and then also volume, because volume, comes from our understanding of area, because volume is simply the area of the base for a particular three-dimensional shape times its perpendicular height. Thank you so much, Lady M at GP. Is that at GP at Gauteng province? Thank you so much for the generosity in the roses there. Thank you. I appreciate you. The heart me. I saw that. 2.1, find the area of the shaded part. The area of the shaded part. Remember, area, like I said, is the space covered within. Now listen, guys. Here, it's saying find the area of the shaded part. So what we want is just the area of the shaded part, which means we don't want the area of this triangle. We want to exclude the area of the triangle. We want to have the area of the rectangle excluding the area of the triangle, So if I was covering this, I want to cover everything within except this triangle. Then they say the triangle in the rectangle has a base length of 3, all right, and a perpendicular height of 2,5. So if I had a perpendicular height, I would see a construction of 2,5. It is just a construction, guys, so that we can have an indication of how tall the triangle is. So please guys, with this area, shaded part and all of that stuff, there's this understanding we need to have. So what would we first do? Okay. Katlego, can you please use a little bit, okay, if you could just eliminate the vulgarity in your language in my comment section, please. I don't really take too kindly to vulgar language, so yeah, the KAK, you could have eliminated it and just sort of like used a more refined, word. We need to try and be a bit more refined in our language, because if you're going to be like this in the platform, I'm going to have to annihilate you a little bit, you see. Yeah, unless you can bump it up and improve the way you speak. Someone once said that when you use a vulgar language, it's a sign of a lack of vocabulary. Like you have a difficulty in finding words that can express yourself without being vulgar. So I believe you have a buffet of vocabulary words that you've learned. Use them, but don't use, otherwise, me and you, I will exclude you like this triangle. I will calculate the area of the other parts and exclude you from the platform like this triangle is going to be excluded when I find the area. So let's find the area of the shaded part. So firstly, if I calculate the area of the entire rectangle, that is like me calculating everything, meaning the shaded part and the triangle. Nothing is excluded. If I decide to do what? If I decide to calculate the area of the rectangle, that will be me like doing what? I will be calculating the area of the entire rectangle, meaning everything will be basically covered, including the triangle. Okay, so if I say area of the rectangle is equal to, guys, you know what the area of a rectangle is, right? Yes, area of the rectangle is, the formula is length, the longest side, the horizontal dimension, times the breadth, the shortest side, the vertical dimension. So my area would be length times breadth. But let us understand that when you do that, area is equal to length times breadth. The 8 centimeters times the what? The 5 centimeters. You get the area of the entire thing, which is what? 40 centimeters squared. Okay, so I need in your head to internalize what we've just done. What we have just done by doing that, okay, is we have calculated the area of everything within this rectangle. Everything, right? That includes even the what? The rectangle, the triangle. That's the area of everything. So if I want to cover this rectangle inside, I would cover it with 40 centimeters squared. If I want to buy a mat and cover this rectangle, I would buy a 40 centimeters squared mat, 8 by 5 mat, and cover it. All right, so that means I'm also covering the what? The triangle. Me, I want the area of what? Not the triangle, but everything else. So the reality is the 40 centimeters squared I have is the area of everything, including the what? The triangle. So what now must I then do in order to ensure that this triangle is not part of the area that I have? That means I need to take this area of the rectangle, which I now know is 40 centimeters squared, and I need to subtract the area of the triangle, which I am going to find just now. So that by doing that, what do I get? The area of the shaded part. So there is this interplay between you actually checking what you have, checking how to get what you've got, the bigger part of everything, getting it, Then you pull out that thing that you need to pull out. How do you pull out? How do you eliminate? How do you remove? You subtract the area of what you want to remove, so that what is left behind is what you want. You want this part, so you need to pull out the area of this from what? From the area of the rectangle. So now let's go and calculate the area of the triangle. What is the formula for area of a triangle? It is half base times the perpendicular height. Where is the perpendicular height? We were told most that the base length of the rectangle, of the triangle has a base length of 3 centimeters and a perpendicular height of 2,5. So let's use that formula. Half e base, which is 3, so we times by 3, times the perpendicular height, we times by 2,5. Then we go and check what do we get as our answer. So we have this half, we times by 3, we times by 2,5. We get 15 over 4, which when we press SD, what do we get? 3,75. So we have 3,75 what? Centimeters what? Squared. So now the area of shaded part is going to be the area of the rectangle minus the area of the triangle, which we know, guys, the area of the rectangle we found most by it's 40 centimeters squared. The area of the triangle we found most is 3,75 centimeters squared. Now we can subtract the two and get our answer, which should be quite straightforward, so that we now know what is the area of the shaded part. Zoda, I got the information that was further given to me from the diagram was the triangle in the rectangle has a base length of 3 centimeters. So that's where I got the 3 centimeters from. And a perpendicular height of 2,5 centimeters. So the triangle also has a perpendicular height of 2,5. So these are where these values come from. All right, I hope you understand now. So this is where these come from. So that's where I was able to then calculate the area of the triangle on its own and then get it. Then you subtract those two guys. So your answer that you get, as sold out is saying to us in the comment section, is 36,25 centimeters what? Centimeters squared. And that's basically our answer. That's how we go about finding the area of the shaded part. So yeah, all right. So all in all, we could have basically answered this question in one line. Once we understand the concept, area of shaded, we take the area of the full minus the area of the part, and then we could have gone ahead and basically written down the area of length times breadth minus the area of half base times perpendicular height. And guys, we could have honestly just done this in one line. Instead of doing 2-part calculations, just doing 1-part calculation. We're taking the area of the rectangle, right? The area of what? The rectangle. So what is the rectangle's area? The length is 8 centimeters. The breadth is 5 centimeters. The area of the full rectangle is going to be 8 centimeters times 5 centimeters. We put that in brackets, minus the area of the triangle. Which triangle? This triangle that is inside the rectangle, because by calculating the area of the rectangle, we'll have the area of the entire rectangle. But what we want to do is we want to pull out, okay? We want to pull out the triangle from this particular rectangle. So we want to subtract it or remove it. If we want to remove that area from the entire rectangle's area, then we want to calculate the area of that triangle whose dimensions we are told. The triangle in the rectangle has a base length of 3. So the base length of the triangle is 3 and a perpendicular height of 2.5 centimeters. So the perpendicular height internal to that triangle is 2.5. So then it means we have the base. We were told it's 3. We have the height. We were told it's 2.5. We put this in a bracket. And then all we do is we get the individual lengths there. We have 40 centimeters squared that we get there, minus we get the individual area there. We get 3.75 centimeters squared. And then our final answer, 36.25 centimeter squared. So these calculations can be done in one line. Instead of doing it, we calculate the area of the rectangle alone, we calculate the area of the triangle alone, then we end up putting things together. We can simply just put it in one line. Area of the shaded region. What is the area of the shaded region? It is the area of the rectangle minus the area of the triangle. For this specific diagram, we can see that would help us in calculating the area of the shaded part. So one line calculation, we simply put in brackets the area of one minus in brackets the area of the other, and then we go ahead and we do our calculations in that fashion, and then we get our answer very nice and simply, and it makes life so easy, and we are very happy, right? Very, very happy once we get that. No problem. I'm gonna do one more. Find the area of the shaded part. Let's check this one out. Check this one out. Once again, what do you want to do? You want to find the area of the what? Of the shaded part. Now you can see the shaded part here. This is like your typical, you remember those houses that you used to draw when you were like 2 years old, 3 years old, whenever you would sit down with a pen and a pencil and they would ask you, please draw a house. You draw that house with one door there with windows and stuff like that. This is how you would draw your house. Do you remember those houses you used to draw? Okay, anyways, you probably still draw them, don't you? Nonetheless, find the area of the shaded part. Okay, so what do we have in this particular diagram? We have 1, a triangle. 2, what type of shape is this? Okay, 10 centimeters, 10 centimeters. So we have a what, guys, here? We have a, I hope you can see what we have. Right. So we have a square here. 10, 10. Very obvious. That is a square. So it's 10 centimeters. Right. Here we have a triangle. The square is very much independent on its own to the triangle. Right. So we can start here within the square and calculate the what? The area of the square. Then what do we pull out from the area of the square? If we calculate the area of the square, what are we going to be pulling out from the square in order to find the shaded area? Because if we calculate the area of the square, remember, what do we get? We get the area of the entire square. All right. Then we pull out the circle from the square. So we are going to have to calculate and subtract the area of the circle from the square so that we can find the shaded region for the square. Then we add on that the what? The area of the triangle. Because remember, the triangle is fully shaded. So finding the area of the triangle is independent on its own. We add that to basically the full area of the square, subtracting the area of the circle. Okay. So you can see that Mr. Panda Bear, Mr. Panda Boy, has said full area of a square minus the area of a circle. Hopefully we understand that understanding. Okay, that would give us the shaded region for the square. Okay, then on top of that, we are going to add the area of a what? Of the triangle, so that we have the full shaded region of which we are being asked here to basically calculate. So what's important here, guys, is to understand the logic. Okay, we want this shaded region. Guys, firstly, what is area? You see, this goes back to those who were here at the beginning. I explained area is the space covered within a two-dimensional shape. So when you look at the fact that this is a square, this is a square, what is the formula to calculating the area of a square? Side times side. The area, the formula for calculating the area of a square is side times side. So if you say 10 centimeters times 10 centimeters, you get the full area of this square, which means you now know the space covered within this square. But remember, when you say 10 times 10, you are covering the entire square, meaning you are including that circle in there. So that means you would have the whole thing, the area of the entire square. But remember, we don't want the area of the entire square. We just want the area of the shaded part of the square. So, to do that, we find the area of the square. We then subtract the area of the circle. Why do we do that? Because remember, when you calculate the area of the square, you are getting the entire covering within the square calculated. We don't want the entire thing. We want just this shaded part of the square. Okay, so we need to then find the area of the shaded part within the square by calculating first the area of the square, right? Then subtracting the area of the circle. By doing that, we have now got the area of the shaded part of the square. Does that make sense? Let's first look at that. Okay, we first find the area of the square. We subtract from it the area of the circle so that we can get the area of the shaded part. For the square, the area of the shaded part for the square. After doing that, you can then find the area of the triangle on its own and add it to the area of the shaded part that you had got from here. From there, you will have the entire area of the shaded part. Okay. So let me actually do this. All right. Okay, I'm just going to read the so we have this, we have that. Okay. We are told that's 10. We are told that's 10. Okay. Guys, do you understand that if, let's just say, I was calculating the area of this square, typically I would just say area is equal to side times side, then say 10 centimeters times 10 centimeters. I get my 100 centimeters squared for the area of the square. This is the area of the square in its entirety. Okay. So guys, in other words, I'm saying this entire square, right? The entire square. If I want to cover the square, I cover it with 100 centimeters squared because that is its area. The space within a two-dimensional shape is 100 centimeters squared. But you see now, they have this circle that is inside here. And we are not interested in getting the area of the entire square. We want the area of the shaded part. And this 100 centimeters squared, guys, does not represent the area of just the shaded part of the square. It represents the area of the entire square, meaning including the circle as well. That's what 100 centimeters squared stands for. It stands for everything, right? Everything within the square. So what we then do to get the shaded part of the square, we want the shaded part, the area of the shaded part of the square. We are going to take the area of the square and we are going to subtract the area of the circle. The area of the current square is 100 centimeters squared. So we are going to take that, right, and we are going to subtract. Now, for the circle, for the area of the circle, what are we given? We are given the radius of the circle, which is 4 centimeters. The radius of the circle, which is 4 centimeters. What is the area of a given circle, guys? The area of a given circle is pi r squared. That's the formula we use. So if it's pi r squared, pi, as we said, is just pi. We multiply that by the radius, which is 4 squared. And then we get our answer, which is 16 pi. But I think from the calculator, Zota there in the comment section had actually indicated what the area of the actual square would be, I believe. I mean the circle, sorry, not the square, the circle. Welcome to Sticky Man Party. Am I right if I say the area of a circle is 2 pi r? No, it's not. The area of a circle is pi r squared. Don't confuse the area with the circumference of the circle, which is 2 pi r. That is the distance around the circle. That's not area. 2 pi r is simply the circumference or the perimeter of a circle. Pi r squared is the formula for the area of the circle. So you are wrong if you're saying 2 pi r, right? 2 pi r is when you are calculating the distance around the circle. If I want to know what's the distance around the circle, I use 2 pi r. If I want to know what is the area, meaning the inside, the space covered within a circle, then I use pi r squared. If I want to know the space covered within a circle, guys, area is simply the space covered within a shape. Okay, so if for the circle I want to calculate its area, it means I'm calculating the space covered within it, the entire space covered within it. That's pi r squared. So I think shift pi, we said 4 squared and we got 16 pi, which is 50,265,482. All right, yeah. But you see, the thing is, we are interested, Luna, we are interested in the entire thing. So if I take that 100 centimeters squared, I subtract that pi 4 squared, which is the area of the circle. This will give me the area of the shaded part of the square. Okay, the area of the shaded part of the square. So this 100 centimeters squared, remember, is representing the area of the entire square. The entire square, that's 100 centimeters squared. But if I subtract the area of the circle, now I only have the area of the shaded part of the square. Right, the area of the shaded part of the square. So 100 centimeters or minus that shaded part, what does it give me, guys? 49,7373. All right, okay, that's very important. Okay, so that means I now have the area of this shaded part. this shaded part, all right? This shaded part of the square. But remember, on top of that, there is also Mr. Triangle, which is shaded on top of this area. So in addition to this area of this shaded part, we also have, in addition, we have the area of the triangle. So that is why we are going to take this area that we got here. We're going to add it to what? To half base times height. This area is going to be added to half base times height because it also includes the triangle. Remember, the triangle here has a height of 6 centimeters. Okay, and obviously if the height is 6, what is the base? Remember, this was a square. This square, its base, remember the opposite side here would also be 10 centimeters. So we have the base of this triangle is 10 centimeters. The perpendicular height is 6. So we have half base times height, which is half times 6 times what? It's half times 10, times 6. The 10 centimeters comes from the side of the square. The height comes from 6 centimeters as from the diagram, because this is a representation of the perpendicular height. Okay, this is a representation of the perpendicular height. Pilisiwe, to say you are so fast rather than asking the question that you want does not help the situation. You know, so I've been speaking, so some of you are quiet. You see, so if there's something, you know, you should indicate in the comment section rather than say you are so fast. Because if you're not indicating, you know, this is the same thing I usually say to my kids at school. Because many times kids will just sit there and they'll watch, you know, they'll watch. And then they'll watch and they'll watch. And then you'll finish. Then at the end, they'll be like, "Sir, I didn't understand anything." That to me is just, I don't know. It's not kind to me. It's not kind to them. Because if there's something you don't understand, you should indicate. Right? Like immediately. Like, so I'm here, for instance, I'm here explaining something, right? And then you keep quiet the entire time. And then at the end, you say you don't understand everything, right? My question is, as you were listening, why didn't you indicate that, "Sir, I don't get that"? You see? It's not kind. It's not kind to the people that are in the audience, because let's say, for instance, 90% of the class understands, you don't understand. By you refusing to ask me the question when immediately you did not understand is not kind. You see, it's not kind at all. So you must ask when I'm somewhere. You must ask. All right. Yeah. So now, to be honest, I am super lost myself. You know. Yeah, I'm super lost myself, and yeah, at what point did I lose you? I don't know. Did you just join in and just type the message, "You are so fast"? Or what? Like, what's the issue? I think now I'm just gonna stop here. Pilisiwe, for instance. Pilisiwe, who are you and when did you join the session? And where are you lost? So that I can pick up where you are lost. Okay, guys, I know I was calculating the area of the triangle. Just that Pilisiwe says you are so fast. You are so fast. So where did I lose you? Or did you join midway? Where is Pilisiwe now? The same. I'm lost who circle. You lost who circle. All right, one more time from the top. Okay, we are given here the area. We are asked to find the area of the shaded part. If you are asking what is the shaded part, maybe even you don't understand that. By shaded part, this circle, for instance, is unshaded. It is not shaded. But here at the bottom, there's this square. Not all of the square is shaded, because the square is shaded only where you don't find the circle. So the square is shaded here, but not all of it. Then there is a triangle. It is all of it shaded. So the triangle is independent from the square, right? Very independent. Like if I calculate the area of the triangle, I will have a portion of what is shaded, right, on its own, because the triangle is shaded, all of it. So if I calculate the area of the triangle, it is all shaded. I'm not going to be subtracting anything from it, because it is all of the triangle. All of the triangle is shaded. Do we get that first? That all of the triangle is shaded. Do we understand that? That all of the triangle is shaded. You know, there's no part of the triangle that is not shaded. Okay, can I get an indication in the comment section that people understand that all of the triangle is shaded? I see Lindelani says yes. Shasha says yes. All right. Now, let's go down. The square. Not all of the square is shaded. The square is shaded only here, as you can see where it's shaded. But the circular part of the square is left unshaded. Hopefully we understand that. Now, if me and you was to calculate first, let's look at this diagram in two parts. Let's first look at part 1 of this diagram and look at part 2 of this diagram. So part 1 of this diagram is the square. The square is affected by the circle. We can't talk about the square without referring to the circle as well. All right. So if we look at the square, we can calculate the area of the square. How? By using a formula for calculating the area of a square, which is what? The area of a square formula is side times side. In other words, the multiplication of the two adjacent sides will give you the area of the square. But once you find that value, do you understand in your head what you mean when you get the answer for the area of the square? What do you mean for the square when you find the area of the square? It means you have just found what represents the inside covering of this two-dimensional shape. You are saying, in other words, it would take 100 centimeters squared to cover the inside of the square. When you get the area of the square, you mean covering the entire square would take 100 centimeters squared. That's what you mean by the area of the square. If you calculate it, side times side is 10 times 10, and you get the 100 centimeters squared. That means the entire square inside the space is covered with 100 centimeters squared. But the thing is, we know that this square has a circle inside. This square has a circle inside. So it's good that we know that the area of the entire square is 100 centimeters squared. But we are not interested in the entire square. We are interested only in the shaded part of the square. We are interested only in the what? In the shaded part of the square. So if we are only interested in the shaded part of the square, it means that from the full area of the square, we need to subtract the area of the circle, so that by so doing, we can get the area of the shaded part of the square. Okay, we need to subtract the area of the circle from this square. So the full area, which is 100 centimeters squared of the square, needs to be subtracted. We need to subtract the area of the circle. So what is the area of the circle then? We were told that the radius here is 4 centimeters. We were told that the radius of the circle is 4 centimeters. So we are going to now calculate what? The area of the circle. What is the area of the circle? Area of the circle is pi r squared. What is the radius of the specific circle that we have here? It is 4. So we substitute 4. We get 16 pi. And therefore 16 pi in our calculator is what it is. Okay, we get that value that we get. So that means from the 100 centimeters squared, we are subtracting 16 pi centimeters squared, which basically will then help us to get the area of the what, guys? By doing this, taking this area of the square, obviously understanding that all of it, we mean that subtracting the area of the circle, meaning just that part, we are now able to get the area of the what? Of this shaded part. Just that shaded part, because at the end of the day, we wanted the area of that shaded part. Okay, but we then said that this triangle, that triangle there, you see that triangle there, it is independent of this square. It has nothing inside, so we can simply calculate the area of the triangle. What is the formula for area of a triangle? It is half base times perpendicular height. Which base? That base. Which is what, guys? Since this is a square, this is 10. That is also going to be equal to what? To 10. So therefore our base is what? Is 10. What about our perpendicular height? Well, this vertical tall, all right, this length here is a representation of how tall the triangle is, and it is 6 centimeters. That is our perpendicular height. Okay, so then you can go ahead and do what? You can add the area of the triangle. Okay, you can add the area of the triangle. So that is why we were saying that the area of the square minus the area of the circle plus the area of the shaded complete triangle, that is what will give us the full area of the shaded part for both diagrams. So 100 centimeters squared minus 16 pi centimeters squared plus the half times 10 times the 6, the 30. You can put this all in your calculator and you should arrive at the answer for the entire shaded part. Okay, the entire shaded part. So what did you guys get, if I may ask you? Okay, what did you guys get as your final answer? I'm gonna wait for you to tell me, because honestly, surely 79,73 centimeters squared, right? And I put everything in there. All right, there it is, my 100 minus the 16 pi plus in brackets the half times 10 times 6, and you get that beautiful answer of 79,73. If you round off to 2 decimal places, it's 79,73 centimeters squared. That is the area of the shaded part. Okay, yeah. So I think just for ease, okay, just for ease, yeah, remember what I did here is I actually, let me just type this in again. So the 100 minus, remember it was 16 pi, okay, 16 pi, 16 pi plus, and of course we have the 10 times 6, which is 30, so it's like in brackets you have the 1/2 times 10 times 6. Yeah, that's 79,73. Yeah, so what's important here is to ensure that, yeah, our full rounding off, it happens there when we are complete. So the individual values that you get, hence I'm saying it's always nice when you do these calculations on one line, so that your individual values, when you get them, you know, you can simply obviously just go ahead and put things in your calculator and get the final answer. Okay. For the radius was squared. 4 squared is 16. All right. So it is 16 centimeters. Okay. 16 centimeters squared. 16 pi centimeters squared. Okay. There. The radius of the circle is 4. That's 4 squared. 4 squared is 16. The pi is there, centimeters squared. So that's where we got 16 from. Okay. Njabulo Muna. Yeah, hope that makes sense. I think some people here don't need to be here, to be honest. Some people here don't need to be here. Okay, if you are a troller, please, yeah, I think some people are just here for the sake of trolling. If you are a troller, please don't, yeah. What do you mean? It makes a huge difference. I really appreciate it. Okay, that's great. I'm happy it does. Okay. Okay, Panda, I think you are not supposed to be here, actually, honestly. I think I see your comments. You are actually a varsity student. I think you just need to not be here, to be honest. So, my leader. And the thing is, you are saying, I think you are just distracting people in the comment section as well. You are helping, but you're not helping. You're helping, but you're not helping. All right, I think let's... You're helping, but you're not helping. I don't appreciate people who help but don't help. Yeah, he's actually helping a lot, but at the same time, very distracting in the comment section. So let me encourage you to, I think he can be very helpful. So individually, if you, I think he's available. Please go and follow him, and I think he can do live sessions and teach you guys. Yeah, we can do that too. Okay, let us look at surface area and volume, because that was the other thing that people were saying that they need assistance with. Okay, so let's just check out this, because in this video already I feel like we've exhausted a lot of the area perimeter and stuff. So let's just look at this. Yeah, so this is grade 8 and 9, guys. Grade 8 and 9, because both grades need to know the concept around volume, surface area, and so forth. So let me just first, before we get into it, let us just come here. So guys, surface area, we look at surface area for 3D solids. Okay, in grade 8 and 9, we look at surface area for your triangular prism. Okay, guys, a triangular prism is something like this. This is what a triangular prism looks like. Okay, this is how it usually stands, and I'm sorry guys for the but yeah, this is how it stands. Okay, this is a triangular prism. Its base is a triangle, so it has a complementing base. There's a triangle at the top, there's a triangle at the bottom. So this is basically a triangular prism. Okay, how many triangles does a triangular prism have? It has 1, 2. Okay, and those triangles are congruent. The two triangles are the same. Then it has rectangles. It has 1, 2, 3 rectangles. That's basically what a triangular prism is. Okay, yeah. So we call it a triangular prism because at its base there's a triangle. Right, 1, 2 triangles. And I'm sorry guys for this sort of like object that I have here, but this is the best I can come up with under the circumstances. So this is what you call a triangular prism. If you take your book and sort of like place it in an open direction like this, you would see also the idea of triangular prism. But yeah, this is what we mean by triangular prism. Okay, so this is a typical example, and when you see it, you are seeing it stand like this. It's sitting on its base. Its base that it sits on is a what? Is a triangle. Hence we call it a triangular prism. Okay. Yeah. So there's the surface area of that triangular prism. Okay. And then there's the volume. Now for surface area, guys, simply put, surface area of a triangular prism, what you want to think about when you think about surface area is what are the shapes that make up a triangular prism. Okay, so as I had said to you, you have 1, so this is 1 rectangle, 2, 3. So you have 3 rectangles, all right, 3 of them, right? So you would want to basically find the area of the 3 rectangles. And added to that, you have also 1, 2. 2 what? 2 triangles. So it would be plus the area of 2. The area of 2 triangles. Okay, so that is what for a triangular prism we are dealing with. Okay, as I said, how many rectangles? 1, 2, 3. All right, and here's the thing. depending on what type of triangle you have. Depending on what type of triangle you have. So if this triangle is an equilateral triangle, do you know what will happen? All these rectangles are going to be the same. If this triangle that I have here is equilateral, then I'm going to have 3 rectangles whose area is the same, right? Because if you look at this area, if you look at this rectangle, for instance, when I calculate its area, what am I going to say? I'm going to say the area of one rectangle is the length of the rectangle times the breadth of the rectangle. Look at the breadth. So the length is always going to be the same for all my rectangles. All of them have the same what? Length or height, if you want to call it that. But then each breadth will depend on the length of the triangle, the sides of the triangle. Okay, so yeah, for equilateral triangle, the rectangles are going to be the same. Okay, they are going to be the same. But if the triangle is a scalene, meaning all the 3 sides are unequal, then what are you going to expect to have? You are going to have 3 different rectangles. 1, 2, 3. Okay. Okay, you have 3 rectangles. All right. Yeah, you can go ahead and run if you have a different formula. Okay, remember that formula will differ. It will differ. All right, it will differ. So the area of 3 rectangles plus the area of 2 triangles. I just need you guys to understand the basics, that you, in essence, what you are saying is you are going to find the area of 3 rectangles, okay, plus the area of 2 triangles. Okay, that's how you will basically calculate the surface area. Okay. Okay, so I'm going to unpack for the different triangles, but for now, I just need you to understand that when you talk about surface area, you are looking at the solid surfaces of this triangular prism. So you have one solid surface, it's a rectangle. Another solid surface, it's a rectangle, it's closed. Another solid surface, it's a rectangle, it's closed. So you have 3 rectangles, as I said. Then you have 2 triangles, okay? They are also closed. If they are solid surfaces and they are closed, then you are talking about the area of 2 triangles. So it's the area of 3 rectangles plus the area of 2 triangles. I need you to first understand that part. Calculating the surface area of a triangular prism. 2. What about volume? Guys, volume is simply, the concept of volume is that volume means the space occupied by a 3-dimensional shape. So for instance, you see, for instance, at the moment, there's this space that is open. The minute I put this triangular prism here, it is occupying, you know, the space where it is standing. Okay, it is occupying the space where it is standing. So that's what we mean by volume, the space that is occupied by a 3D shape. So this triangular prism is occupying this space, right? And the concept of volume in grade 9 and 8 for the prisms that we are learning is that we say that the volume of a prism is the area of the base times its height, the height of the prism. Yeah, so that means from the bottom of the prism to the top, we call that the height. And we use a capital letter H, height, because how tall okay, this particular 3D shape is what we call the height. Okay, from the bottom triangle to the top triangle, that is what we refer to as the height. We are referring specifically to that, from the bottom of that triangle at the bottom to the top. That is this edge that we are talking about. The area of the base. What is the base? So for a triangular prism, the triangular prism rests on its triangle. So in other words, we are talking about the area of this triangle. And we know that the area of this triangle will be the half, the what? The base of the triangle times the height of the triangle. So we say half the base times its actual height, the height of that specific triangle, because we are saying the base of the triangular prism is a triangle. Okay, by the base, what does the triangular prism rest on? It rests on this triangle. What does the triangular prism rest on? It rests on this triangle. Therefore, we say that the base of the triangular prism is a triangle. This triangle that you are looking at, that triangle that you are looking at. So if it's a resting, what you should see with a triangular prism is that there's a triangle at the bottom, the same triangle is at the top. So this here is the base of the triangular prism. So what is the area of that base? The base, we said, is a what? Is a triangle. What is the formula for the area of a triangle, one triangle? It's half base times which height? The height of this little triangle there. Remember the base, there at the bottom. The height we know from the top to the bottom of this triangle that you see in front of you. Okay, then we multiply that. So the area of the base is half base times height. Okay, then we multiply by the height, how tall the triangular prism is. We're looking at the entire prism, how tall the triangular prism is. That is the H, the capital letter H. How tall the whole entire triangular prism is. That is that capital letter H. It doesn't allow you to what? What are you talking about? It doesn't allow me to. What doesn't allow you to? Okay. Oh, it doesn't allow you to type. I think it may be because of my restrictions there. Okay, let's see if you can. You try again, just try again. Okay. Okay, that's the volume, whatever. Okay. Now let me go directly to an example so that you guys can internalize. So we are given this diagram. Okay. Now, do you see we have the triangle? The sketch shows a prism with a triangular base. So what you are seeing here is a certain type of triangle. Okay? Yeah. This triangle is the same as this bottom triangle. This is a triangular prism, but it's resting on its triangle. This is like something like this, guys. This is kind of, they've drawn a diagram to represent this. You see what you have now in front of you? This is it. This is what you're looking at. You're looking at a triangle like this. Okay. What you can see here, this rectangle, here it is. It's this rectangle that's looking at you. right, where my thumb is. Then the triangle itself, they've drawn, this is the triangle that they're speaking about, the one at the top. Then at the bottom, there is that triangle at the bottom. So this is a triangular prism, and it is resting on its base triangle. Okay. It's resting on its base triangle. Okay. Okay. Okay, I think, Lindelani, the only problem I have with the formula is that where is the, you said 2BH, right? Remember that for a triangle, one triangle, the formula is half base times height. So my question is, why did you say 2BH? Yeah. Okay, so, but I love your formula. Okay, but it's just that I have a problem with the 2 that's outside the BH. I think that's where I'm failing to understand. But I'm going to use that formula of yours. Okay. Okay. So I've written down the formula. Don't worry, and I'll clarify what needs to be clarified when I go through the problem. Okay. So here it says the sketch shows a prism with a triangular base. Calculate the following. Show all your calculations. Firstly, they want the volume of the prism. Now you remember very well that I said that the volume of the prism, we need to know what the area of the base is. Our base is a triangle, but remember this triangle is the same as that one. So all we need is to first find the area of the base, meaning in other words, the area of just the triangle. Do we have enough information to be able to write down the area of the base? Because remember, the formula for the volume of a triangular prism is V is equal to half. We are looking at just the triangle as a base here. Okay, that's all we are looking at. We are looking at just the triangle, this triangle alone, which is the same as this triangle, which is the base of my triangular prism. This triangle, it has a height, this triangle, just this triangle, guys, has a perpendicular height of 30 centimeters, and then it has a base of 16 plus 16, which means 32 centimeters. So it has a perpendicular height of 30, it has a base of 32. So I'm going to do this, half the base, 32, times the height 30. Okay, remember I said the volume is the area of the base. What is the base? It is the triangle. The triangle at the top, which is the same as the triangle at the bottom. Where the triangle is resting on this triangle, that is my base, all right? So I'm calculating the area of this triangle, because volume is the area of the base times how tall my triangular prism is. So half base times height is just the base, the area of the base, the area of that triangle at the bottom, whose base, the triangle itself, is 32 and whose height is 30 centimeters. Can I just get an indication that you guys are following me so far? That I'm wanting to calculate the volume of the prism. The formula for the volume of a prism, whether it's a triangular prism, whether it's a cylinder, whether it's a cube, whether it's a rectangular prism, the formula says, guys, the area of the base of that prism times how tall the prism is. Now, we look, what is the base of a triangular prism? We said the base of a triangular prism is this triangle at the bottom. Then we ask ourselves, what is the base of this triangle? The base of the triangle is actually the 32 centimeters, because we are just looking at this triangle. This triangle is the same as that one, guys. So that's why when I'm referring to this triangle, I'm actually also looking at this triangle. I see the information here. So the base is 32 centimeters. Okay. Then what is the height of this triangle, which is my base? It is 30 centimeters. So that's why I have here half times 32 times 30. This is me calculating the area of the base of my triangular prism. But remember, the formula furthermore says the area of the base you need to multiply by how tall the whole entire triangular prism is. So I have to then multiply that by the capital letter H. The capital letter H is an indication of how tall the triangular prism is. So when I say how tall the triangular prism is, I have my triangular prism there. From the bottom of this triangular prism to the top, what is that? From here all the way to the top, that is basically 50 centimeters, guys. This is what we mean, 50. You see, you look at the diagram, look at the actual picture. From the bottom to the top, that's 50 centimeters. Are we together? So I'm going to multiply this entire thing by 50, because this is my height of the entire triangular prism. This is how we calculate volume, guys. This is very important. The area of the base of that specific prism. You identify what is the base of that prism. It is a triangle. What is the area formula for triangle? It is half base times height. Go and identify the base of this small triangle. What is the base of this triangle? What is the height of this triangle? Okay. Does that make sense, guys? So then there it is. The area of the small triangle times the big height. How tall the triangular prism is. How tall it is represented by this 50 centimeters. The entire prism, how tall it is. Then you can put this in your calculator, all right, and get the volume. Now remember, guys, this will give us the volume, but our unit of operation for volume is not square units, it is cubic units. Cubic units, let's not forget that. So we put this, we times that, we get 48, and then we multiply that by 50. We get 24,000 centimeter cubed. Okay, that is the volume. So in other words, the space occupied, you see this is empty space, but the minute I place this prism, it occupies a certain portion of space. When we measure the portion of space occupied by this triangular prism, we say that it is 24,000 centimeters cubed. So when you calculate volume, that's what you are calculating. You are calculating the space occupied by an object. Okay. Are we together, guys? Yeah. Now, let's move on to the next question that they asked. The total surface area of the prism. The total surface area of the prism. The what? The total surface area of the prism. You're very welcome, Nonjabul. Very welcome. I'm glad that is helping, because I don't see any other practical way of understanding volume and surface area. Learners get lost all the time with this thing, and they just think of formulas and substituting. And if you don't understand the diagram and understand the aspects attached to the diagram, it's very difficult to even do this. It becomes a pain. And learners hate measurements. Why? Because they don't understand to begin with what they are dealing with, and they can't relate it to anything that's tangible, you see. So it's better to understand and see something tangible. Then my grade 8s and 9s, the total surface area of the prism. I told you, Moss, that our total surface area, when we talk about surface area, we are in actual fact saying how many triangles do we have? We have 1, 2 triangles. Then how many rectangles? You have 1, 2, and then 3. Now, the formula that my friend said, I think it was Lindelani. You shared the formula there, and you said that surface area is equal to 2BH plus H into A plus B plus C. I can agree with this part of the formula. This one helps you with the 3 rectangles I was speaking about. Remember, I said that the total surface area of a triangular prism is the area of how many rectangles? 3 rectangles plus the area of 2 triangles. Okay, the area of 3 rectangles plus the area of 2 rectangles. So what we know for a fact is that when you look at this diagram, we can see that for this rectangle, for instance, the height will represent the length of this rectangle. We look at this rectangle number 2, the height will represent the length of that rectangle. We look at this rectangle, the third rectangle, the height will represent the what? This rectangle. So all 3 of my rectangles will basically share the same what? The same height. Now remember, I said that the 3 sides of this triangle will be the breadth of each rectangle. And depending on the type of triangle you have, then those breadths of your rectangle may be different or the same. Let me repeat this one more time. Each rectangle, rectangle number 1, you can say rectangle number 1, rectangle number 2, rectangle number 3. These 3 rectangles share the same height. Or in other words, for the rectangle itself, we would say they share the same length. But we call this length in this triangular prism the big capital letter H, right? So that is one thing that is common for all 3 of my what? Of my rectangles. But if we look at the triangle, depending on the type of triangle we have, rectangle number 1, if the triangle is an equilateral triangle, rectangle number 1, rectangle number 2, and rectangle number 3 are going to have the same what? The same breadth when I calculate their area. But if the triangle that I have is another type of triangle, then of course, guys, those sides will be different. And basically the area of each rectangle will show that the sides are different. So what I like then about this formula, okay, if you look at 1, 2, 3, this is representing the 3 sides of the triangle. Okay, because remember, if I'm calculating the area of this rectangle, it will be the height times the breadth, which is the side of this one rectangle. If I look at this one, I'm changing the side of the triangle. If I'm looking at this one, I'm changing the side of the triangle. So that's why it makes sense that you talk about H times A, that's one rectangle, plus H times B, that's another rectangle's area, and then plus H times C, that's another rectangle. So when you say H and then you put brackets, A plus B plus C, this A and this B and this C represent the sides of the triangle, which are the breadth for the individual rectangles. Okay, so this A, this B, and this C represent the sides of the triangle, right? But these are the individual areas of the 3 rectangles. So the area of 3 rectangles, that's fine if we say H into A plus B plus C. All we simply substitute here is the 3 sides of the triangle. We check what are the 3 sides of the triangle. We give the one side, we give the other side, we give the other side, and then we multiply that with the H, because that's like finding the individual areas of each rectangle. So this part of the formula I agree with fully. This is how I would calculate the area of the 3 rectangles. The height, basically from here, from the bottom to the top, is consistent for all 3 rectangles, so that H is common, but then the sides of the triangle will be different depending on the triangle that it is, or it will be the same. If it's an equilateral triangle, all 3 sides will be the same, which is fine. Okay, this part, I said the area of 3 rectangles plus the area of 2 triangles. So if we are saying 2 triangles, what is the area of 1 triangle, guys? The area of 1 triangle is half base times height. 1 triangle is half base times height. That's 1 triangle. But remember, we want for how many triangles? 1, 2. So we are going to say the following. So we want for 2 triangles. Remember, 1 triangle's formula is half base times height. So then if we have 2 triangles, then that means our formula can simply be written in the following format. 2 times half. What's 2 times half? Okay, we know this 2 and this 2 will cancel. We are left with B times H. So it would make sense, Lindelani, if your formula from your teacher was actually this: B times H plus capital letter H, A plus B plus C. Then it would make sense. So that's why I was saying I am not in agreement with putting 2 there on the outside and saying 2 breadth times height. No. I do not agree. All right. Rather, if you're going to write this as your general formula for surface area, then I 100% fully agree that the total surface area of any triangular prism can be represented by B times H plus H into A plus B plus C, close brackets, and you can always substitute into this. It will always work out every time. I don't know if anyone has any particular questions or concerns that they have. So now that we understand the concept of total surface area, then we can move on and actually see how we calculate, and we can substitute and use the formula to get the answer. You're very welcome. Very welcome. But as long, guys, as we are clear, okay, this formula here comes about because we understand that we have two triangles, not one. Okay, we have two triangles. The formula of one triangle is half base times height. So because we have two triangles, we multiply by 2 so that we can get the area of the two triangles. So base times height is a representation then of the two triangles and their area. The formula then would be more simplistic and applicable in this situation. Okay, so let's come now and check. Yeah, so the A, the B, and C represent the sides of the triangle. The H represents how tall our triangular prism is. Okay. Then of course, okay, let's check now how to calculate the total surface area of this prism then. And then we can move along and see. So first and foremost, if we look at the triangle, okay, if we look at the triangle, we are good. We can get the breadth and the height of the triangle. I mean the base and the height. We have that. We have the 32 and we have the 30. Okay. Yeah, and that's basically it. Okay. But let's say I did it the long way and said 2 half base times the height. Okay. Then it's 2 half the base is 32. The height of this triangle is 30. Okay. Then this part, guys, the question is, do I have the 3 sides of my rectangle? I have the height, which is 50. That's no problem. But do I have the length of the 3 sides? Do I? Okay, I have this side. That's not a problem. That's 32. Remember, for this rectangle, I'm sorted. But then there's this rectangle, this one. Okay, I don't have the length for this side. So I need to find it. And how do I find the length of this side? And I need to find the length of that side too. But I think if I find the length of this side, since this is 16 and that's 30, that's also 16 and that's 30. If I have the length here, I will know what the length is there. So you see, guys, that I need to use, as you have said in the comment section, the Pythagoras theorem. And what does Pythagoras say? It says that the square of the hypotenuse side is equal to what? The sum of the square of the other two sides. So I'm going to have to find this side. So let's go ahead and go find that side before we can even substitute into the what? Into the formula, because we are missing elements of the formula so that we can get the total surface area. So if I use Pythagoras, let's just say it's c squared, and then say 30 squared plus 16 squared, using Pythagoras, of course. So 30 squared plus 16 squared. 30 squared plus 16 squared. We are not subtracting, Remember, it is the hypotenuse that we want. 90 degrees is opposite the hypotenuse. So we say the square of the hypotenuse side. That's what the definition of Pythagoras says. The square of the hypotenuse side is equal to the sum of the square of the other two sides. Okay, so we don't say 30 squared minus 16 squared, rather we say 30 squared plus 16 squared is equal to the square of the hypotenuse side, right? Hope that makes sense. So we have 156. We take the square root of that. We get 34. All right. We get 34. 34 what? Centimeters. And that's important, that 34 centimeters. So now that we have 34 centimeters, it means that we have 32, 34, that's also going to be 34. So now we can say h into a plus b plus c. That means h is what? Is 50. That is 50. A, now remember the three sides of the triangle. We can say a here. 76 squared plus 7 squared. I don't understand what you are saying. What in the world? What are you saying? What are you saying then? Did I write it incorrect? 30 squared plus 16 squared is 1156. I don't understand what Nokutenda is saying there in the comment section. I have no idea at all. I'm lost. You need to explain yourself. What if it says 76 squared plus 7 squared? What part? Oh, you mean from your calculator? Oh. What kind of calculator are you using? That's my question to you. Okay. Then guys, three sides of the triangle. This is 32 for this rectangle. This is 34 for this rectangle. This is also 34 for this rectangle. So I write my h, which is 50, and then I say 32 plus 34 plus 34 in my formula. Okay. No, then you can't say 30 squared minus 16 squared. Now you are messing it up now. The square, Pythagoras says the square of the hypotenuse. The hypotenuse is the side opposite our 90-degree angle. That's how we identify the hypotenuse. The square of the hypotenuse side is equal to the sum of the square of the other two sides. That's 30 squared plus 16 squared gives us the hypotenuse squared, please, right? So you say c squared is equal to 30 squared plus 16 squared. You write your reason, Pythagoras. 30 squared plus 16 squared gives you 1156. You take the square root on both sides. You write the answer. C is equal to 34. So the answer is 34. So that means this is 34. And then since this is 34, you can see this triangle, this right angle triangle is the same as this right angle triangle. It would mean that this is also 34. So we know that this is 34 for which rectangle? This rectangle. We know that this is 34 for which rectangle? This rectangle. And then we know that this is 32 for which rectangle? This rectangle. Okay. Then you are able to actually go to your formula. Remember, this was for the area of the two triangles, okay, plus the area of the three rectangles. The area of the three rectangles, they share a common length, all right? And then these are the three sides of the triangle. The three sides, this side, that side, and that side. You add those two add those three in brackets, you multiply by 50. All right, and guys, all we simply do is we take our calculator and we can punch all of this in so that we get the answer. Okay, we have 960 here, and remember this is squared. On this side we have 50. 32 plus 34 plus 34, which gives us 5,000. And then you can add these two together, 5,000 plus 960 centimeters squared, which gives you 5,960 centimeter squared. And that pretty much wraps up that particular problem. Okay. Yeah, my good people, I'm going to have to end the live here. I'm going to have to end the live here because other priorities call for my attention right now. But I hope this was helpful. Okay, this was helpful. Yeah, you guys, I'm going to obviously download this and load it up into my YouTube channel. But yeah, I don't know when I'll be live again. You guys just need to understand, it's very hard for me to actually say when I'll be live. Let's ask Lindelani Mavuso. Lindelani, you must send me message-wise. Send me a message with the formulas. It seems like Lindelani has the formulas. Then I will post what Lindelani sends me. Remember, the 3 additional prisms that you need to know are your rectangular prism, right? Yeah, rectangular prism. Okay, we know rectangular consists of, and every time it depends, guys. Okay, but we know that we have how many rectangles? Okay, and depending on which base it is, sometimes you have a rectangular prism that has a square base, but sometimes you have a rectangular prism that has a rectangular base. All right, yeah. Okay, then we have the cylinder as well, and the cube. Right, the cylinder and the cube. So volume, surface area for cylinder, volume, surface area for cube, and volume, surface area for rectangular prism. The grade 8s and 9s need to know up until that point. Okay, so please share those with me in the Mago, so then I will actually screenshot and load those up onto my homepage. All right, and guys, just remember once again, like I said, I'm planning to have a grade 9 in preparation for grade 10 early preparation sessions that will be happening during the holiday. It might possibly also happen during the course of next week, but it's at a price, guys. It's not free, it's at a price, which is why you'd have to speak to your parents about it and let them know and see if they would be fine with it. If the interest is there and you'd like to be part of that, do send me a private message. I will send you the details about that. I will send you the details. I can't share the details here. I'll send you the details privately. Then you can send those to your parent and check with them if that is fine. Because at the end of the day, we can't do something like that unless your parents know. Because I then intend to have those individuals become part of a WhatsApp group that I can actually work hand in hand with. So hopefully we can do that, and I'll see you next time. Yeah, so cheers, have a good Sunday, and please do take care. Practice and practice and practice. Also do the NS. If you guys are writing GEC NS, please do the NS. Practice for NS, learn the NS, pass the NS, distinctionize the NS, distinctionize everything, guys. We are in the movement of doing that. And that's why, for instance, with this early grade 10 preparation, those kids that actually become part of that, my intention is to assist you, not only now, but depending on whether you want assistance moving forward, even for next year, then we can do that too. All right. Yeah, many learners that have actually shown consistency, because remember, guys, I'm not responsible for your performance. How you do at school, I'm not responsible for it. You can message me personally. You can send me a message via TikTok. If you follow me most, you can message request and send me a message there. You don't know how to inbox Lindeland? You can DM me on TikTok, man. You know, don't you know that? How will I message you personally? Don't kill me here. I've had many people send me message requests. Yeah, you don't. Well, Lindelani, ask someone who can. I think Ink FFX actually did send me a message, for instance, about that. So I just need to update and send him the message or her the message that relates to this arrangement that we'll be having for those grade 10 early preparations. So those people will be able to get the link. I will tell them ahead of time, I'm going live on this time. They'll be able to join in my sessions, but not only just join in, they'll be able to guest request. I'll accept their requests. They can talk to me live and ask questions so that they can vocalize their problems, not just talk there in the comment section. Then I will switch off my comment section so I don't see anything, and those people will be the only ones I'll be able to see anything that has to do with communication and conversation. Well, so what a great way to actually ensure that these people are getting all the attention that they can possibly get. Then also, those people also get like my WhatsApp number. They'll be able to be part of a group and will be able to communicate anything. If you need help at any time, you can let me know of help, and I'll give you that help and assistance when you need it, whenever you need it. If you want to voice note me about something, clarify anything, maybe you are being taught something, you want clarity about it, I'll always be available for you at your fingertips. So that's basically the perks. But like I said, it's at a price. So what I will do is, like I said, I need to first send that communication to you. You can escalate it to your parent, and then they can approve. If not, then I guess not. If yes, then I guess yes. And guys, I'm not the only person who's helping out on this platform. There's many other helpers. So don't think that it's only me. No, it's not only me. In the Lani Mavoso, next year definitely we'll be rolling with the physics as well when it comes to physics, grade 10 next year. So next year I'll be starting doing physics and the life science so if you need that additional help as well for grade 10, I'll be assisting with that too. So guys, thank you so much. I can't really extend this live any further. I have to end it here because I have other commitments I need to attend to, but I'll definitely see you again. Thank you so much. Cheers, guys. Tech science, everybody's asking about everything. Don't you just wish like I could just split myself into many people and just do all of these things in all of these platforms? Maybe with AI it's possible. We'll just have to see, eh? We'll have to see.